I'm John Wazinski, the Executive Director of America Makes, and I wanted to just give a quick recap of what we heard on day one. So we had a couple of updates from our team at America Makes talking about what we're working on and where we're going. You saw both from the operational side as well as the technology side and the education components of what we're doing. And then we were able to bring in some external content that really started to ask the questions about where is this technology going, and maybe most importantly, what's needed moving forward. And we're, ourselves reflecting on that and thinking about what does the next phase of the Institute actually look like. And I'm sure folks are wondering how to get engaged and what the opportunities are to get engaged. So we'll talk today about a couple more ways that you can get involved. In particular, this afternoon, if you're part of the technology side of the community, there's going to be an update from our Roadmap Advisory Group chair, which he'll talk through what we're doing and ultimately where we're looking to take things from the technology side of the business. We also are very fortunate this morning to be kicking off with opening remarks from Dr. Lay from the Office of Secretary of Defense from Research and Engineering. She is relatively new into that position, but has offered some comments up. So we're really excited to have that and make that available to you. In a minute, I'm going to ask our executive committee chair to come to the stage and kind of introduce himself and introduce the executive committee and the concept and what they're looking to do moving forward. There was a great question that came in yesterday. So as you heard from me, we understand awareness and communication are a big need across the community. That's something that we are taking to heart and working on. Moving forward, you'll start to see a lot more out of that. One opportunity to get engaged, however, and I mentioned yesterday, and I'll put some slides up here, in between and going into future breaks, but we have a new Rapid Innovation Call topic that is actually open as of yesterday for teams to put proposals together around. Remember, the idea of a Rapid Innovation Call is something where, someone in the community comes up with the idea and they very quickly, we process whether that aligns to the vision of the Institute, or not necessarily the vision, but, an opportunity that we can take on at the Institute or not. If it falls into that category and gets pushed through the executive committee, it then gets made available for teams to bid against. But we want to turn these opportunities as quickly as possible. And you'll see that when you look at the RFP, there's only a couple of weeks available for you to actually put together your responses. And then last thing I wanted to just briefly talk to is when we go into back into the break, you'll notice a number of different logos spread about the showroom floor or the floor area. There's one that has America Makes events. If you click on that, it'll actually show some of the upcoming events. We have scheduled another game day for November, and we've scheduled a mini TRX for December, which is going to be taking on the topic of standards and really, starting to re-engage in that conversation. And we've been working with the SDOs about that or on that topic. So you'll see the various additional opportunities where you can get engaged and be part of the discussion. And then you'll see more and more of that coming out over the coming weeks and months. One last note that I wanted to make before I hand it over to the chair is that we had to make a little adjustment to the schedule. Just for those of you following along, I know a lot of people come in and out of this because of really busy schedules that everyone has. But the time slot where we were going to be covering the America Makes satellite centers from 12 to 1 Eastern, we ended up having to pull that off, and we're shifting a couple of the talks around a little bit. So at 12 o'clock, we're going to have the Amnl presentation from our own Ashley Toten. And then at 12:30, we moved up just one time slot, the briefing from NSF and Kevin Show. So that'll give a great opportunity, and we heard this yesterday evening from a number of participants. We'll end up having a longer break, which is what we initially had hoped to do, but there was just too much content. So we'll end up with a 1 hour opportunity to network at the lunchtime hour. So with that, really appreciate everyone coming in, spending time with us today. Hopefully there's value in what we're talking about. Please use the chat. If you have general chats, put them in there. If you have private chats, you can go out and find participants. I really encourage you. I'd mentioned, nearly 600 register. We had almost 400 show up yesterday over the course of the day, but you see people come and go because of the realities of all of our schedules right now. So I encourage you to take a look in there, see who's here, direct message them or private chat them. And the final note that I want to make, and we utilized it very well yesterday, but the Q&A function. So as people are talking and people are providing briefs, please put your questions in there. We really want to make sure that we're engaging with the community, the membership, really addressing the topics that you want to have addressed. So with that, I will like to bring to the stage Ambassador Barnes. If you're out there, sir. I would normally be waving to you, but I can't see you right now. There he is. Oh, look at this. That is beautiful.
Thank you, Dr. Holzhauser. As we said, I put the ass in ambassador. So good morning, good afternoon, good evening. So I'm privileged to represent the executive committee as the chair this year. From yesterday, there's obviously a great deal of interest in where America Makes is going. And I think that's a great segue into what the executive committee is. And so by definition, the executive committee is the main strategic advisory group for the Institute, focusing on strategy, policy, and advocacy. As John mentioned in his remarks yesterday, it is the voice of the membership. And so I think we take that quite seriously. Some of the people on the committee I know personally for many years, and others I'm just getting to know, but they all take this responsibility, I think, very seriously. They're all have been actively engaged in the community and definitely want to see the maturation of additive manufacturing. So the executive committee is comprised of 3 appointed government representatives, 8 representatives elected from 3 sectors within its membership community: nonprofits, academia, and industry. And the committee members serve 2-year terms. I am the chair of the executive committee, which I believe has to come from the industry component. So I volunteered, and/or my colleagues took one step back, and so you're left with me. The first meeting of the current EC, we just started our 2-year term in 2020, was at the Rellis campus of Texas A&M, the satellite campus back in March, which coincidentally was the last plane ride that I ever took this year. So quickly, I'd like to point out who is actually on the executive committee. So from the nonprofit sector segment, we have Stephanie Gaffney, Director of Advanced Manufacturing Program at the Youngstown Business Incubator, Janine Kuntz, who's the Vice President of Tooling U SME. And then on the academic front, we've got, I think, the hardest working woman in universities, Sandra DeVincent-Wolf. She is not only the Senior Director of Research Partnerships at the College of Engineering, she's also the Executive Director of Next Manufacturing Center and the Director of the Manufacturing Futures Initiative at Carnegie Mellon. Ed Herderick, a lot of you would know, is the Director of Additive Manufacturing, the Center for Design and Manufacturing Excellence at The Ohio State University. And on the industry front, I'm joined by Melanie Lang, co-founder and CEO of Formaloy, Jim Monroe, the AM Director of American Additive Manufacturing, and long-term colleague of mine. We actually got my first start in metal additive back in the 90s with Brian Rosenberger, who's a Lockheed Martin fellow at the aeronautics company in Fort Worth. Then we're joined by our government colleagues, Raymond Clinton, who is the Associate Director, Science and Technology Office at NASA Marshall. Alan Pence is the Additive Manufacturing Implementation Lead, Deputy Assistant Secretary of the Navy, RDT&E. And then we've got Mike McKittrick, who is the program manager of R&D Consortia at the U.S. Department of Energy, Energy Efficiency and Renewable Energy and Advanced Manufacturing Office. So having introduced that incredible team, we're here to represent the membership and to really help John plot the next couple of years. So we're a forward-looking group, and I think we're very lucky to have the members of the committee that we have. With that, John, if in fact the story is true from Scientific American this morning, there's a 50.22% chance this is all just a simulation. Hopefully it's going well.
On my microphone, turning it back on. But yes, let's. I don't know what to take from what they said, but yeah, my calculations are a little. Hopefully, it's a little less chance of that, or I don't know. Who knows at this point in time? But yeah, really appreciate the executive committee. We started off, and then the COVID hit, and it's been a bit of a challenge for the few months. But I think there's quite a bit of opportunity moving forward, and I see that they truly are the voice of the community and the voice of membership. So there's representation, as John just walked through, across all of that are similar to each one of you that are sitting out there in some way, and really ultimately represent your voice. So I encourage you to reach out to them. You'll start hearing a lot more. We're going to try to each month bring in one of the different advisory groups and working groups, just to make sure we're connecting the dots between the other activities that are going on at the Institute, as well as with the EC. But they're ultimately the ones that are helping me and the team look forward, as we all look towards, what does this need to be, over the next couple of years, and then really beyond. We're gonna certainly need some help, because there's lots of challenges out there. So thank you, sir. Appreciate you taking the time this morning. Appreciate all you're doing for us and with us. I'm now I'd like to introduce the next topic, which is a welcome briefing that will get queued up here from Dr. Jen-Fen Lay, the Principal Deputy and Acting Director of Department of Defense. So at OSD, there's a group, Research and Engineering and Technology. That is the group that Rob Gold, who we've had speak a couple of times, and Tracy Frost, who many of you are very familiar with. They fall underneath her chain of command. So she recently got moved into this position over the summer, and she ultimately directly reports to the head of R&E at OSD and the CTO out of the White House, Dr. Krastios. So she's going to give a couple of opening remarks. There's a few key points in there that I'd like everyone to hone in on, and it's really about the future, and it's about the vision of the department and where they see opportunities to continue to work with public-private partnerships. So if we could queue up that video. Hello, everyone. I think I really appreciate the comments. I think the last few seconds of that got cut off at the very end of the recording that they did for us. But I think the message overall is pretty clear. Dr. Lay and the team at DoD are thinking hard about what is the relationship between the government and public-private partnerships and the innovation institutes. Just to make sure everyone's clear, she said one thing in particular that everyone should understand, and it was specifically referencing a process, or a strategic process, as she called it, to build out and evaluate the progress and the value that the institutes are providing at the end of their formal agreements. So just so everyone understands what that means for us, at America Makes, you may or may not be aware, but we have had multiple cooperative agreements, actually, whereas some of the others are still finishing out their initial first cooperative agreement. We finished our first cooperative agreement. We have a second agreement in place, which we've done a tremendous amount of work against, that is closing out, and we have a third cooperative agreement that got put in place or the very end of last year. So we are on the docket for review, not for another 4 or 5 years in this formal process, the way it's currently being proposed. So just so everyone understands, the model is one that they in some ways did that with us already, and there is a new cooperative in place, kind of building off the successes of what's been done today so far. So with that, just wanted to clear that up. Really appreciate the comments, certainly appreciate the support from the Department of Defense. And I want to now transition into our keynote, the team from our keynote briefing. So there's a group of folks that we've gotten pretty close to over the last year and really build some relationships with. And Aaron O'Donnell, our partnership director, has played a big role in that and helped foster these relationships. But the team from the NFL is here. They're going to talk a little bit about innovation. They're going to talk through, many of you may be aware that the NFL safety challenge, or helmet challenge rather, took place here in Youngstown, Ohio. So we've got 3 folks on, Dr. John York, Jeff Miller, and Dr. Jeff Crandall. So they are all here right now. I will handle it over to you, gentlemen. Thank you for taking the time out this morning. Appreciate hearing an update from you.
Well, I'm going to start off. I'm John York, and I live in Youngstown, Ohio, and our family owns the San Francisco 49ers. The NFL is full of exciting competition among great athletes and ingenious coaches. There's another side of sports, and that is injuries. The NFL started collecting injury data in 1980 with a single medical officer and 2 team physicians and athletic trainers in each club. Today, the NFL has a medical department and many consultants forming committees for foot and ankle, lower extremity, turf and shoe, head, neck, and spine, behavioral health, engineering, epidemiology, and pain management. Regarding NFL injuries, the 20 most common injuries may be divided into 3 severe injuries, including ACL, Achilles, and concussion, with the first 2 injuries often season-ending. The other 17 injuries are a variety of soft tissue injuries, of sprains and pulls. And while these injuries are less severe, they are common, and there is more accumulated time loss with these injuries than the more severe injuries. Turf toe was the NFL's introduction into additive manufacturing. Turf toe occurs by hyperextending the great toe beyond an angle that is needed for athletic competition. The NFL engineers found that if this angle is limited to 72 to 78 degrees, then a player has full range of competition and almost no concern for injury. With turf toe, walking is painful for 4 to 6 weeks, let alone playing football. One recommended treatment for play is a steel shoe plate, preventing flexion but also inhibiting performance. My friend Mike Garvey at M7 Technologies and I both live in Youngstown. Mike and I discuss a lot of things, and he introduced me to additive manufacturing, America Makes, and a new world of product design. For turf toe, what if one could design a shoe plate which initially acts similar to a regular cleat, but as the angle of flexion approaches 72 to 78 degrees, the shoe plate stiffens to avoid the great toe reaching that danger zone. We began looking at a potential 3D printed shoe plate with these characteristics. And so far, we have not been successful for a number of reasons. The problem seems more complicated than initially imagined. The cleat manufacturers showed little interest in a remedy. That's not additive manufacturing, that's the shoemakers. The NFL moved to improve field surfaces and the entire cleat. So that was the first taste of additive manufacturing, but there is more. Around the turf toe shoe plate time period, concussion became a huge international issue in all contact sports. The NFL efforts had focused on the medical aspects of concussion, which includes diagnosis, treatment, and protocols. Doctors are less trained in the prevention of concussion, so the NFL turned to engineering and epidemiology for prevention, while still working to improve diagnosis and treatment. Jeff Crandall, Biocore engineer, and Jeff Miller, NFL Health and Safety, summoned the helmet manufacturers to improve safety using models developed by videography, impact testing, and other means at Biocore. The helmet industry did improve, and these new helmets use new 3D printed linings. Initially, Visus out of Seattle and Rydell using a carbon ink shell started this trend in improvement. The two Jeffs, Mike and I, even visited Carbon, located near the 49ers practice facility. Crandall and Miller continued their quest to find improvements through scientists, engineers, and innovative companies. They decided to hold an NFL helmet challenge to spark interest in a radically new helmet design. While this NFL thought process was bubbling, I continued to talk with Mike Garvey about these ideas. And in the spring of 2019, Mike suggested the NFL might benefit by visiting the Rapid Exposition in Detroit. Crandall, Garvey, Miller's associate, and I met in Detroit for the expo. We met small and large companies, some with great interest in the NFL Helmet Challenge. We needed to find a way to entice the innovative additive manufacturing community to attend and provide radical concepts for the NFL Helmet Challenge. On the ride back to Youngstown, Mike and I brainstormed and started connecting dots. As owner of the 49ers and living in Youngstown, I touched two of the dots, the NFL and the Youngstown location. Mike owned M7 in Youngstown and was part of America Makes. America Makes is headquartered in Youngstown, and Ralph Resnick and Aaron O'Donnell knew how to gather the additive manufacturing community. This started the plan to bring the NFL Helmet Challenge to Youngstown so that the additive manufacturing community could assist with an improved, safer helmet. And now I will turn it over to, I believe, Jeff Miller to talk about the NFL's project.
Thank you, Dr. York, and appreciate the introduction and the history there. And we at the NFL are exceedingly appreciative of John's leadership on health and safety issues, which, as we all know, for those of us who are fans of the game or work around the game, are always the league's priority to ensure the health and safety of our players, whether it relates to the foot and ankle injuries, concussions, and obviously this year, in this very unusual year, COVID. But back to the point, I'm thrilled to be here to present with America Makes, who has been a terrific partner for us as we've thought through new and innovative ways to create incentives for people to build better protective equipment, specifically helmets. And so it's a real honor to be here and re-engage with this community, who I know is full of thought leaders and entrepreneurs and innovators to help us reach that goal collectively. And the event that we held in Youngstown a few months ago was a great jumping off point to that. And our effort with the Helmet Challenge has proven to be successful already, as we've gotten in a number of great and new ideas. So I'll speak for 1 or 2 minutes longer here about how the NFL got to this point where we were focused on concussion and some of the work that we've done around helmets, and then turn it over to Dr. Crandall for a much more technical perspective on this to engage with this audience and the larger community. But Jeff, maybe we can throw some of the slides up there. I just had a couple that I wanted to walk through with the group to orient them.
Sure. I am sharing the screen, but it won't seem to let me, Jeff. So I don't know if there's a technical person
All right.
that could step in. Maybe you can get started and they can help.
Yeah, I can. Go ahead.
I can share for you. If you just want to say next slide, we'll move on.
Perfect. Thanks.
Of course.
Terrific. So here's a little bit of background on how we keep track of some of our progress on concussion. These are the last 5 years of concussion statistics. that we've kept. Notably, if we jump to the end here, we've seen a significant decrease in years 2018 and 19 over the previous years. And this time frame here represents the amount of time that we've spent on what we call our engineering roadmap, with Dr. Crandall leading and Dr. York leading, as we've tried to get our arms around the frequency of concussions in the game, the sorts of injuries the player suffers, and the contributions that the equipment makes to that. The notable decrease there over the last couple of years is one that obviously comes as a sign of progress for us, but also an indication, given the number, how much more work yet needs to be done. And so we created a strategy. We can go to the next slide. A few years ago, around 2016, when Dr. York and his fellow owners agreed that they wanted a concerted, disciplined effort led by engineers and doctors to try to better understand concussions on field, the hits that cause them, and then to direct ways to decrease those numbers. And those were it was a threefold strategy. First, on the engineering side, to create incentives or disrupt the helmet industry to some degree to create better equipment, which Dr. Crandall will go into in detail. Second, was to take a look at the rules of the game and start to eliminate certain practices or behaviors that were especially disadvantageous to player safety. And we've made any number of rules changes, not just over the last 5 years, but going back further than that, to offer greater protections for players. Some of the engineering work had a substantial input into that as we better understood the injuries on field and were able to better target some of the behaviors that led to some of these injuries. And therefore, we're able to identify rules changes that could lead to those. For example, we implemented a rule this would be the third season, on use of the helmet, lowering one's head to initiate contact. And that's a frequently used technique that players, especially on the defensive side of the ball, would utilize to load up the force in their head, neck, and spine when they were tackling players. Unfortunately, led to concussions, especially among the tackling player, but also potentially put a lot of strain on the spine. We saw that in too many cases across the league. Those behaviors have been targeted and have begun to be eliminated from the game, and we've seen the results, the beginnings of the decrease of concussion. A lot more work to do in that regard. And the third part of that strategy was to really imagine what our preseason practices would look like. Are some of the drills that our players engage in and their coaches allow necessary for the purposes of teaching the game? Is there too much head contact? And if so, where? Around what position groups? And so with a focus on that over the last couple of years, we've eliminated some drills that have existed in football for many, many years. And coaches have been very innovative in how they've thought through how to coach the game and teach the game in ways that begins to remove the head as was originally designed. So maybe Andrea can go to the last slide there of my group before I turn it over to Jeff. Here's the roadmap as it was. You'll see it was a 5-year effort there, which really gets specific around understanding what happens on field, mapping at this point more than 800 concussions against more than 150 different variables, and taking a look at that data for a better appreciation for the types of hits, the types of helmets the players wear, replicating some of that those forces in laboratory testing meant to replicate on-field hits that cause concussion. Sharing with the players, importantly, which helmets do well in the laboratory and the correlate as to the risk factors that they have on field, and encouraging players to choose better performing helmets. And in fact, for the first time at the NFL level, prohibiting certain helmets in conjunction with our friends at the NFL Players Association. And so we've seen over the last couple of years, as an example, more than half of the league change helmets, move to what we call green, or the better performing helmets. We have a chart that hangs in every locker room to help players make good decisions around which helmets they wear. And we believe, and this is the part of transition over to Jeff, we believe that there's a lot more to be gained in helmet technology. We've seen substantial improvements. John mentioned some of the new innovators in this space, not just the incumbent manufacturers, but other entrants who have joined. And I think that's pushed that helmet industry to a better and safer place over a very short period of time, based on the discipline and the work and the research and development that the league has done. So to go into more details around that and talk about our next steps, I'll turn it over to Dr. Crandall, who's a biomechanical engineer down at the University of Virginia and is the lead engineer on our engineering work, not just for helmets, but on all the other elements that John mentioned, but here to talk about helmets and concussion. So with that, Dr. Crandall, take it away.
Thanks, Jeff. Maybe next slide on Dara. So what I'm going to transition to is a discussion of some of the technical aspects of a helmet. And I thought, just at its basic core, if you look at a helmet, and over on the right-hand side here, you see we're pretty limited in terms of the number of components. We've got a shell, we've got a liner, we've got a face mask, and we've got a chin strap. And so from those 4 basic components, we have to address a number of different roles or functions. First and foremost, the primary purpose, the sole purpose of wearing a helmet is to keep the athlete safe. And so safety is the primary function, but then obviously comfort and fit, the mass or moment of inertia, it has to be durable, has to allow heat transfer, and has to sort of pass the mirror test from an aesthetic standpoint. And so what I'm going to do is I'm going to walk you through, you've seen that Dr. York and Jeff both mentioned sort of where we've been with the safety of helmets. I'm going to walk through more from a technical aspect. Next slide. If we look at that, the function of a helmet is how does it manage or control motions and forces to minimize the risk of head injuries such as concussion. And over on the left-hand side of the screen, you'll see that I've put a couple different sort of motions here: translational motion of the head, rotational motion of the head. The fact of the matter is there's a number of ways in which the head can be loaded that produce concussion. And one of the first steps biomechanically was let's come up with a metric that describes the risk of injury given a set of forces or motions to the head. And the reason we needed that metric was not to necessarily to understand risk alone, but to bring that metric into the laboratory to be able to evaluate helmets. Jeff mentioned that we put a poster out each year on how well helmets manage the forces based on this injury metric. And then to use in design, we need to help the sort of manufacturing community have a target for what they're trying to minimize when they design a helmet. Jeff also mentioned on the right-hand side, we've looked at a number of concussions. I think between practices and games, we are looking at over 1,000 concussions. And what we want to do is, if we understand the on-field environment, what we can do is say, let's replicate those forces and motions that are occurring on field. Let's bring those into a laboratory environment such that when the manufacturers and entrepreneurs are going to design helmets to minimize that injury metric, that they can do so and it's reflective of the on-field. And so we've developed a test methodology and we have a metric. And so I think we have the core elements of what we need in order to change design moving forward. We understand the environment, we understand the metrics. Next slide. So if we look historically, and if you look over on the left-hand side, you see this laboratory performance. So that's the sort of metric here. And the lower the forces or the lower accelerations, the better you do. So the closer you are to the bottom, the better. And if we look historically over the past 30 years, what you'll see is that the sort of reddish colored line here represents pre-2015 on how models introduced in any year sort of performed on average in laboratory testing. And so you see a decreasing slope. That means helmets were performing and reducing forces and accelerations, and so it was improving. You see a sea change around 2015. Now, there were a number of things that were happening, some new manufacturers, some innovation in the helmet manufacturing community, as well as Jeff mentioned that the NFL and the NFL Players Association got together and started testing helmets with this methodology and with this metric. And you see that we had a pretty big increase in terms of the rate of improvement on an annual basis for how helmets tested. And in fact, a helmet made after 2015, the rate of improvement in performance in lab tests was about 9 times what it was before 2015. And so this is great. This means this increasing performance means we're going to reduce injuries on field. And Jeff sort of showed you how the last couple of years that's borne itself out. Next slide. But we would, even though this was a big change in improvement, we would consider this sort of evolutionary improvement. And what we really want is you know, Jeff showed you, we still have more concussions than anyone would like on field. And in order to address that, we really need to get to sort of revolutionary improvement or transformational improvement. And so how do we go about that? We had already seen, as Dr. York alluded to, that additive manufacturing could play a role in many components that we were looking at. It already had played a role in some of the helmet designs with Vicis and Riddell. And so what we wanted to do was develop a way where we would incentivize or stimulate the development of these advanced helmets. We wanted to bring in a broader community. We wanted to bring in sort of researchers, scientists, material scientists, advanced manufacturing to develop a helmet that significantly outperformed anything being worn by current players. And so if you look at that from a sort of technical standpoint on a design objective, given a set of impact conditions, we knew what was happening on field. We shared that with the community. How do we minimize the metric, how we're evaluating helmets, how we're rating helmets, subject to design constraints. We wanted it sort of helmets to be within the volume and mass constraints of what exists right now. And so we put this challenge out there. The total funding is around $3 million. And I'll go through it and how that's been awarded and or will be awarded. Next slide. So one of the things that we were convinced was that this could not be solved in a sort of traditional experimental or empirical way. We needed to get to a computational framework. We need to get to simulation. And so what we did is we contracted with 4 universities. We had them reverse engineer commercial helmets. And then we put those helmet models out into the innovation community for helmets. So we sort of seeded them with a computational framework. The idea is these could be used for parametric studies, much better than you could do experimentally. And we could do true optimization. Next slide, please. The other thing that I think if you look at, many people will say is that the best helmet is the best fitting helmet. And this has not been widely addressed historically. If you look at the upper left, what you'll see is the traditional measure is just sort of Stetson size or circumference. And we obviously know that head shape varies considerably from individual to individual, even with the same circumference. A few years ago, we started some measures of height and breadth coming in. But I think maybe 2 or 3 years ago, the scanning of heads and getting to a customized or personalized fit became available. And you see down below, these are the shapes or modes of variation that you see to explain some of the variation. But you see relative to, there's a gray head that sort of underlies that. The red images, the red are sort of scans of the sort of typical representations of NFL players. The gray is the standard head form that's used for evaluating helmets. And so I'm not sure how well it shows up, but there's large variation, obviously, in head shape. And we need to address that if we're going to optimize performance. Next slide. And so if you've got the head shape and you've got an available volume, the question then is, how do you optimize the management of energy in that volume given a head shape? And so this is what we see as the sort of next frontier. How do I fill the sort of design space with materials and structures that most effectively manage the energy for a given head shape, given an on-field environment that has specific forces and velocities? Next slide. So Dr. York mentioned the symposium. One of the things that we did as part of this helmet challenge was we said, let's share everything that we've garnered for information over the last 4 or 5 years. Let's put this out into the community. The finite elements models are out there. The statistics on what's happening on field are out there. Everything we know, let's get it out there and let's bring in a much broader community of innovators and entrepreneurs. This is a very challenging project, and it's a goal, obviously. And we want to get teams that are very multidimensional and get some outside the box thinking. In order to promote that, following the symposium, we put together a grant funding program where we said, give us your best pitch for doing an innovative helmet. We had 100 submissions, and through that process of narrowing down, there were actually four awards given for almost $1.5 million. These are helmets that are transformational in some way, and you see the companies there in the middle. And universities involved. There were 4 awardees. But if you look over on the left, you see that there's a much broader base of companies that were supporting them. Large chemical companies and material companies, 3D printing, universities, lots of folks in there that you will recognize from additive manufacturing. And so their goal is to produce a prototype in roughly a year that uses these advanced techniques. Next slide, please. And I think if you look, this is a sort of composite, and I know it's a busy slide, but what I'm trying to show you is this is a composite of what the companies have actually submitted for proposals and how they're approaching their plan. And the important takeaway here is everything that we could envision as opportunities for advanced design, advanced materials, advanced structures, and advanced manufacturing were all incorporated into these proposals, and they're all being worked on by these grant recipients. So everything from, true optimization, computational framework, testing of materials that are outside conventional materials used in helmets, topology optimization, all of them are using 3D printing to one extent or another. So it's truly a sort of change in the approach to helmets. It truly has the potential to be transformational. Next slide, please. So while we had those 4 awardees, we recognize that there's still a much broader community that we want to submit prototypes for evaluation for this sort of transformational helmet, this next generation. And so the middle of next year, we've actually got a competition where there's a $1 million prize, and people can submit a prototype that they've developed. We've put specifications for the test, specifications for the metric, and specifications for how we're going to rate or rank helmets. And it's basically a competition. You submit your best solution to a helmet that is transformational, significantly improves protection relative to what exists right now, and we'll put it through a battery of tests and evaluation, and then award a number of prizes to the winners. Next slide, please. So again, the goal here was to incentivize the community, stimulate the community, bring in some of the resources that were being used in other areas beyond equipment. And the hope is that in the very near future, we get a transformational helmet. But I think beyond that, what we would hope is that we've laid the groundwork for a framework that changes not only helmet design, but sports equipment design moving forward. We brought in sort of the best of other areas. We brought in different groups and different facets to allow true optimization. And in the helmet in particular, what we want to use is this helmet challenge and the framework we develop as sort of a springboard for not only a sort of general all-purpose helmet, but actually to use that to develop position-specific helmets. So our next frontier is the same way we've looked at concussions overall. We're looking at concussions for specific positions and developing, say, for an offensive lineman, they have different helmets than a quarterback. Let's give that specificity, let's use that framework, and let's get to position-specific helmets as our next objective. So that's my last slide, Jeff, and Dr. York, if I'm back to you, or questions, or...
We're certainly happy to take questions if anybody has any, right? Any otherwise, on Dara, back to you.
I would just make the comment that I think you can all see the impressive biomechanical engineering that Jeff Crandall and BioCore bring to the NFL. And even though that is impressive, it is not until we started to communicate with America Makes and the additive manufacturing community that some of the directions that we're going in have blossomed. So we thank the community, and we look forward to continuing to work with the additive manufacturers.
Well, good morning, gentlemen. It's a pleasure to see you again. Thank you, Dr. York, Dr. Crandall, and Jeff for participating in our MMX. If you do have time, we have at least 2 questions we want to ask. They were highly voted, so I'll allow whoever seems the preferred method to answer. Actually, one says additive manufacturing is highly suitable for customization of any product, especially safety products. Is the NFL and the ownership looking to provide individually customized safety products? And I know, Dr. Crandall, you kind of touched on that with by player position, but maybe add or elaborate a little bit more.
Yeah, so I think the NFL's role, as we see it here, is to sort of facilitate or stimulate or assist the development of these. It's obviously the the manufacturing community, the entrepreneurs that are going to develop the final products. Having said that, we fully believe that customization, specification, personalization is in fit in other areas is a way to get much improved comfort and much improved performance. So anything we can do to assist that, and we think additive manufacturing, one of the reasons we were so excited about this sort of relationship with the additive manufacturing is because we think that is the most efficient and effective way.
Absolutely, thank you. One other question is, the rigid outside of the helmet is sometimes used as a weapon. Do the test methods framework make it so that there's attachment to the current paradigm of a rigid outside?
Yeah.
Do you want me to take that one too, Jeff? Yeah. So, you know, this is one of the balances. As I said, if you look at a helmet, its sole purpose in theory is to be a safety device. It is not intended to be used as a weapon. And so I think a good analogy here is like a seatbelt. You can design an effective seatbelt, but you also need speed limits in order for that seatbelt to be effective. The design of the helmet has to be within the confines of the structure of the game. And Jeff mentioned the rules. And so there's three components. We have education, enforcement, and engineering. Let's design the helmet. And if people are using helmet that's very effective, if people are using helmets as a weapon, the rules component comes in there, and we have to get that.
Let me just add, I think that for those that on the program that are football fans, you've probably seen over the last couple of years an uptick in some of those unnecessary roughness penalties where players are in fact leading with their helmets. In fact, a couple of ejections already early this year for players leading with their helmets. We know that those techniques, those behaviors are quite risky. And so to the point about some deterrence against using the helmet aggressively is a point that we'll continue to enforce, and I'm sure that the rules will continue to reflect it as we move forward in this effort to make the game safer.
All right, so I don't know if we have more time for questions, but I do have a comment that was voted the most. Not a question, but a comment. I hope this technology is being pushed to all levels of play, since most athletes never play professionally. And I know we've had this conversation during the symposium, but I don't know if there's an update to that piece, if you're familiar with other universities incorporating the technology and engagement with this challenge.
Well, certainly on the leadership side or the business structure side, the NFL is operating here, and we're the ones who put this together, and we're the ones with the resource to put this together. The communication down through the colleges is a maturing area, and certainly they've benefited from improved helmet technologies themselves. Down into the high school and the youth levels, I think that takes a little bit more time because of the cost of some of the newer helmets that have been produced. But some of these companies likewise have created youth models with some of the newer technologies in there too. So I think that probably is a place where we need to continue to focus. Obviously, there's a lot more people playing high school football than there are playing in the NFL. But to the extent that this group and our partnership can lead to better protective equipment, whether it be helmets or shoulder pads or other things, I think the entire football ecosystem is going to benefit from it in a very short time frame.
Excellent. And knowing that I probably have about 1 minute left, I'm going to go with the probably the easiest is what does the NFL spend on helmets per year approximately, and what is the market size? I don't know if you have a general.
Well, the NFL doesn't spend any money on helmets. We spend money on helmet research. The individual clubs, as John can tell you, purchase the helmets for their players. And you're talking about a roster of, inclusive of their practice squad, of nearly 70 people, probably with at least 2 helmets each, times a varying cost element for these helmets, which can be upwards of $1,000, so they'll probably on average considerably less. So I think that's probably a ballpark estimate to figure out the budget there. John, it's your line item on your budget.
You're fairly accurate. I would say that the number of helmets that cost $1,200 has increased. We do not require that the quarterback and the star receiver and the star running back and the star edge rusher are the ones who get the best helmets. The players choose their helmets. We were told by the older helmet manufacturers that players decide on the helmet they're going to use in high school, use the same one in college, and want the same one in the NFL. When we started to put out the data about the reduced risk in concussions using different types of helmets, the rush to new helmets was unbelievable. It just blew away that old idea that players would not change helmets. If you give them the data that shows safety, they will go to that helmet. I think today that we have less than 10 players that are not in green helmets throughout the entire league.
Wow. That's fantastic. Well, gentlemen, thank you so much. I appreciate your time. I appreciate the update. I hope to look forward to getting some more feedback and updates from you. And you all stay safe. And thank you so much again.
Thank you, Aaron.
Thanks.
Thank you. Take care.
And back to John York. Or I'm sorry, John Wazinski.
Yeah, no, thanks. I really appreciate that. Thank you, Aaron. I think this is, it's a great demonstration of where additive can fit in and where it makes sense. And, we heard Tim Simpson at the end of yesterday when talking about business case. Sometimes it takes these insertion points to, ultimately get us closer to the point where it becomes more pervasive. And I think we also see that unique connection between, the material side of things and then really the design for additive playing a big role. But it's all really about, to me, understanding the product requirements. And obviously they do and have the resources to put quite a bit of attention to it. So we can see a next logical evolution into things like soldier safety. And we already heard them mention opportunities for youth, whether it's youth hockey or field hockey or football, there's lots of opportunity there. So, my question next would be, that's great. Not many people have the resources of the NFL. And maybe they don't truly understand their product requirements either. So how do we take the next step? Our next talk is going to be given by one of our own, Ashley Toten from America Makes, who is leading a program called Amnl, which is looking at, how do we better understand product requirements, and how do we then use those to build a supply chain? So none of this becomes really pervasive until we have a supply chain and we have digitally distributed manufacturing. That's what Ashley is going to solve for us, and she's going to give you an update on what that looks like in the Amnl program. So over to you, Ashley.
Thank you. I am just sharing my screen here. Let's see. Okay, thank you, John, for that introduction. So good afternoon. My name is Ashley Toten. As John mentioned, I'm the project engineer for America Makes, and specifically for the Amnl program, I am the deputy program manager. Today, I am going to provide an overview of the Amnl program, the activity that is currently going on, and the impacts we are making with this program. The Amnl program is focused on supporting Army readiness through a robust digital additive manufacturing supply chain. To start things off, I wanted to show how the Amnl program is developing the digital thread. We are not defining the entire digital thread. We are showing avenues and opportunities to capture a piece of the digital thread. This graphic shows the pieces that make up the digital thread from design all the way to disposition. The gray box in the middle is what Amnl is focused on, the sourcing, production, and delivery of the parts. The Amnl program is also doing some simulated qualification and certification and simulated maintenance. We are then digitally linking the sourcing, production, and delivery with the Advanced Manufacturing Intelligence Platform, or AMIP for short. So I'll be referencing AMIP a lot throughout this presentation. Because we know there are many useful tools developed by many system suppliers to address specific areas and capabilities, We didn't want to determine which system to use, so we took a step back and created an open standards-based architecture platform. AMIP is a platform that defines a workflow using an open set of standards. It is unlimited rights to the government and is capable of interfacing with IoT devices. In addition to creating and demonstrating an open standard-based architecture platform, there are additional aspects we are addressing through the program. First, we are elevating the supply chain relative to additive manufacturing, making it more robust and more responsive to Army needs. This program is a regional effort, and the region we are focused on is the Tech Belt region, which is defined as Northeast Ohio and Southwest Pennsylvania. We are using this region to lay the groundwork, more of a proof of concept that can be deployed throughout the country. We are working with the Regional Manufacturing Extension Partnerships, the MEPs, to identify the small to medium manufacturers in the region and how they can participate in the Army digital AM supply chain. Supply chain assessments have been executed to understand the current capabilities within the region. Gaps that have been identified are being addressed through supplier development activities to assist in closing the gaps and elevating the supply chain. Second is a focus on elevating the AM processes to become more robust. In order for a reliable digital supply chain, some of the AM processes need to be matured. So we are doing this through process and material development and also pushing complex Army use cases through the supply chain. Third, because we are collecting digital data, we are also providing a visualization capability to the Army. This will not only allow the Army to examine the supply chain, but also interact with them. The Army will be able to visualize the supply chain on a map and view the current capabilities. An open standards edge device will allow us to collect data of a supplier's manufacturing process, which will also be accessible to the Army. This will allow the Army to be confident in the parts they are receiving. And a motto of this program is source with confidence. The next slide provides an overview of the Amnl program partners. So the Amnl program is funded through CCDC AVMC. We have NCDMM is the program lead doing the core program management. We have the Youngstown Business Incubator leading the supplier outreach and development for Northeast Ohio, and Catalyst Connection, the MEP for Southwest Pennsylvania, leading the supplier outreach and development for their region. We also have the Barnes Global Advisors as our experts in additive manufacturing who will be working to help address technical challenges with TDPs in developing process and material specifications. Our primary AMIP development team consists of Quotient, Lex Energy, and StrongKey. Our academic research partner is the University of Alabama in Huntsville, who provided expertise in the supply chain assessment strategy for the program. We also have Advanced Engineering Solutions, who is focused on the modeling and simulation aspect of the program for the Army use cases. And we have GCH Coach assisting with the contracting aspect of our Amnl projects. This slide provides a high-level program schedule. The program is a 3-year effort that began in October of 2019 with an Army and supply chain assessment that concluded in late March. The conclusion of the assessments led to a parallel development effort. So you can see there's this advanced manufacturing intelligence platform, which is being developed in parallel to exercising the AM supply chain through projects. So you'll see that right in the middle, and I don't know if you guys can see my cursor while I'm talking, but here is what I'm talking about. We have advanced manufacturing intelligence platform being developed in parallel with the AM supply chain participant projects. We call these groups 1 through 6 our participant integration projects, which are represented with the little bubbles. Specifically, groups 1 through 4 are providing feedback to that AMIP developer development process by collecting data and testing the digital thread components. In addition to the AMIP platform being developed and the participant integration projects, we also have the advanced process development projects that are being conducted. And these are focused on advancing the technology through the development of the process and material specifications. You'll see at the middle, FY 2021 third quarter, we have a go live. This is a critical point for the program. This is where the AMIP system transitions from development to demonstration. At this point, the supply chain is now being responsive through the AMIP platform in preparation for a series of validation projects, represented by supply chain prototype evaluation on this graphic. We are utilizing the developed system from this point forward for validation. Also on this chart are anticipated efforts for follow-on phase 2. We are anticipating integrating with some Army systems. We also have an OEM advisory board and hope to integrate with their systems and also provide proprietary software tools and services integration support. During the Amnl program, we will be utilizing 19 Army use cases. Instead of just picking parts geometrically challenging or material challenging or process challenging, we tried to combine all of these aspects so we could begin addressing specific problems that exist within the current interests of the Army on transition parts. This is how we selected our use cases for the program. In addition to exercising the supply chain and demonstrating the digital connectivity, we are forcing the Amnl team to finish process specifications, material specifications, and overall TDP packages. We are reducing the risk towards qualification and certification for these parts and parts like these by using a very disciplined coupon test plan. We are conducting inspection and testing to validate the components requirements are met. Not only are we doing this to show we can digitally capture the data, but we are also capturing coupons that can be handed off to the qualification and certification personnel. So our program plan covers 4 AM processes: laser powder bed fusion, material extrusion, multi-jet fusion, and binder jet across 7 different materials. To exercise the supply chain and elevate their processes, we are incrementally increasing the complexity of the projects. To do this, we are ranking the parts based on category and complexity. So the first table is category. This defines the use case criticality initially defined in the Amnl Phase 0 program, which impacts TDP definition, post-processing, inspection, and data capture. For the Amnl Phase 1 program, the category of components used ranges from D category to B. For this program, we are not using any A category parts because it is highly unlikely that small to medium manufacturers will be producing these types of parts in the near future. We believe category A will stay within the confines of the major OEMs due to the mission critical nature of these parts. Complexity displays the complexity of the part build for each project as defined by the Amnl team. So this table shows the part increases in complexity as the geometric complexity increases and the post-processing steps are added. If you combine the program schedule that I showed, the 19 use cases, the category and complexity of the parts, you will get this detailed project breakdown. This is quite an eye chart, so I will walk you through this. So first, on the left, we have under task, this is our 3 different sets of projects. So we have participant integration, advanced process development, and prototype validation projects. Under supply chain depth, this displays the depth of the program by identifying the processes and materials that will be explored for each project. The column titled Number of Sources displays the maximum number of suppliers that will be awarded to participate in the Amnl program to produce the Army relevant use cases. The current plan has approximately 100 individual projects being awarded to the suppliers. Supply chain breadth. These columns track the growth of the supply chain in terms of the complexity of the TDP, build, and post-process steps. The parts increase in complexity and category throughout the projects. The part reference column displays the 19 different use cases. In the participant integration projects, the same use cases are used multiple times, so you'll see the part reference is repeated. But for the validation projects, which is lower in the graphic, we are using 6 brand new parts during these projects to validate the system. You'll also notice that the post-processing steps are incrementally being added, and in the validation projects, all of them are selected. The digital thread columns display the data being collected or sent by the AMIP platform. So you can see how the digital thread elements are increasing through the program. And last, the rest of the columns show the project schedule. So next I want to touch base on some of the deliverables that will be coming out of this program related to the AM technology advancement. So we will have a regional AM digital supply chain database and a capabilities visualization tool for the U.S. Army. So that will be developed and provided. The Advanced Manufacturing Intelligence Platform, AMIP, will securely link the regional supply chain participants to a cloud repository representing the future Army or OEM point of interface. We will have over 19 different parts being manufactured across 4 different processes, 7 different materials, with increasing levels of post-processing requirements. A definition of baseline operational, which includes our statement of works that we're developing for these projects, and our fabrication processes, which are our TDPs that we're developing and the associated specifications such as material, process, and test specifications. So those will be, a baseline will be provided and will allow us to build confidence and repeatable quality across a spectrum of the parts, material, and process types. We will also have a body of knowledge linking the results of operational and build process information captured with the resulting quality for a series of fabricated Army relevant parts. So we will be testing and inspecting the parts. We will know the condition of the part and the process data that was collected during the build of the part. So we will be creating a body of knowledge linking those. People can understand the relationship between the process information and the result of the part. And we are creating an entire system to collect all of this information. And through all of these deliverables, we are creating a scalable platform capable of connecting the United States industrial base of small and medium manufacturers to the U.S. Army and DoD OEMs. Next, I want to focus on a couple impacts that we're having to the digital AM industry. So as part of the sourcing piece of the digital thread, we started with the contracting, so all the way at the beginning. We are exercising the supply chain by going through terms and conditions and negotiations that a DoD contract requires. A lot of our supply chain participants have never done this before. We contracted an expert to help navigate the contract flow downs as written in a typical contract and make them understandable to small businesses. And we are addressing these gaps by providing supplier support, such as webinars, to the small and medium manufacturers. But more importantly, we are taking the industry to the next level by adding digital process monitoring and reporting as an integral part of the contracting process. So the diagram on this slide reflects a typical system. So we have the cloud, which represents the cloud application AMIP, so our Advanced Manufacturing Intelligence Platform, which is a secure Gov Cloud space. And then we have the manufacturer facility represented. So how this works is the operations report description and the production process description, they come down from the AMIP cloud to the supplier. An operations report then gets developed from the data that was collected through the edge device, from the printers and the post-processing equipment, and then the operations report gets uploaded to the AMIP cloud for the government to review. So we are showing the government how to exercise a contract with respect to this digital deliverable. We are impacting the industry in the contract realm. A second impact is we also identified there is a cultural barrier with embracing the technology centered around connectivity and data. In addressing the cultural barrier, we discovered that the operational process monitoring is essentially a precursor to the fabrication process monitoring. It is easier for the manufacturer to provide data such as build time, shop humidity, build sequence ID. So we started with the operational process monitoring data to bridge that cultural barrier. Then it's an evolution to fabrication process monitoring. This is how we will slowly break down that cultural barrier. We are demonstrating the benefits and value of a digitally connected supply chain to the manufacturers. We are also empowering the manufacturer to control the distribution of their digital information. So there's all kinds of data in the manufacturer's database, which will be for their internal company use only. The manufacturer controls the sending of the information. The manufacturer will be able to review and confirm what is in the operations report before being sent. There will be no competitively sensitive data sent in the report. So we are addressing the reluctant and hesitancy and concern head-on in the Amnl program. So over the next 2 years, we hope our open standards-based architecture makes an impact for the U.S. Army supply chain. And with that, I would be happy to take any questions if we have time.
We have time and you have questions, so perfect. I think you've covered a little bit of this at the end, and there's a couple of comments here, but I'll ask them anyways, and you can add in some more detail. I don't know. You can see the questions in the right-hand pane, Ashley, just so you click on Q&A, just so you can see some of the comments. So the one that is at the top right now, it really just shot up here in the last seconds. How do companies protect IP when using Amnl open source model? So I don't know. There's a couple of comments from Joe in there. I think maybe addressing it a little bit, but if you want to cover that.
Yeah, so I kind of touched base on it at the end regarding, everything that's being developed, isn't going to be shared to that cloud without the manufacturer's sign seal approval. So we have that going on. We also have, a lot of security aspects going on to protect and encrypt the data that's being collected through the edge device. So there's a lot of different pieces going in to protect all that IP. And, if anyone has additional questions and would like to follow up, after, feel free to shoot me an email and we can discuss, because I know these are going to be short answers and I can provide a lot more detail if you guys would like.
Yeah, I think that's one of the key takeaways in general. This is a program where there are potentially opportunities to get engaged depending on, what type of business you are. And ultimately, there should be quite a bit of learning across, no matter who what type of organization you are. So next question here. Let me skip down. Those look like responses from Joe. What is the incentive for industry when we have to provide unlimited data rights? So the question there is really why?
So that's a great question. So a part of all the Amnl projects are statement of works, are RFPs that are going out. So if you receive one of these statement of works, you'll see that all of the deliverables are unlimited rights to the government. This again is basic, operational data, build time, shop humidity, temperature, stuff like that. We're also doing like a build file review, but we're not requiring you to send us your build file because we understand that is kind of, your personal IP and all your fun stuff over there. So we're not touching that. But we are collecting the data, that is a deliverable, and we are collecting the hardware, which is a deliverable. Again, that data, you will sign off on it before setting it up. So if there's something you're not comfortable with, we will work with you. But again, we are starting with that operational data.
Yeah, and I think there's a clarification down below, and you really just hit on it. But the data that you're talking about is relative to the AMIP platform, not necessarily. I always forget the acronym. Not the vendor data. So we're really just trying to get our arms around information. That's a critical step towards moving this whole this idea of digitally distributed manufacturing forward. The only way that's going to work is being able to exchange information. So thank you, Ashley. This won't be the last time we talk about this. It's a big program going on. You got to see a little bit of the breadth of what the program is taking on. So we expect to provide updates back to the membership, and really there's opportunities to get engaged. So if you've got questions for Ashley or the program, please reach out and we'll get you connected. So thank you very much.
Thank you.
So we're going to transition now to a very different topic in a lot of ways, and this is something that I'm very excited to be hearing more about, even myself, and that is what's going on in the basic research community. We have historically had some good connection to NSF, and I think we see a big opportunity to bring together the basic research community and the applied research community, and making sure we're informing one another. So Kevin Chow from NSF is going to give us an update on the AM portfolio at NSF. So good day, Kevin. Over to you, sir. Your slides are up.
All right. Thanks, John. Good day, everyone. I'm very happy to here representing National Science Foundation to provide our perspective. More importantly, to show our support to America Makes. NSF has continuously provide support to additive manufacturing research since even like 1980 or before, and is a strong partner to America Makes. Many of you are aware, and as also John has mentioned yesterday, America Make was designed to tackle the TRL 427 apply R&D in the industry, and on the other hand, National Science Foundation here, we found fundamental research, low TRL, 1 to 2, and mostly in the industry setting. And so there's mostly in the academic setting, so therefore there's a strong synergy between the two that we can leverage our experience and expertise to further propel the additive manufacturing to the good of the industry as well as the society. So today, I just want to give a brief general view regarding the fundamental research in additive manufacturing supported by National Science Foundation. So next slide, please. So here's my outline. I know most of you are aware of NSF, but allow me to take a few slides, talk about NSF in general, its organization as well as the program. And then I will talk about how NSF has been engaged in additive manufacturing research, followed by the funding mechanism and some opportunity that exists. And then I will share several examples of our recent award in additive manufacturing area. And if time allows, I'll be more than happy to answer questions. So next slide, please. So NSF, National Science Foundation, even though we have the foundation in the name, we are actually a federal agency. So the three important parts in our mission. The first one is regarding the progress of the science. And the second one is to advance the national health, prosperity, welfare. And then the third one is to secure the national defense. As to what we do, NSF provide support to fundamental research in pretty much all science engineering fields. The only one exception is the medical science. And we also want to make sure that the research is nicely integrated with education. And the chart on the left shows the academic basics research supported by NSF as percentage-wise compared to the overall federal agency. So as you can see, if you look at all science engineering field, we support about 25%. And if you look at just the engineering field, that's about 50%. So that's a very large portion of the funding support to university. Next slide. So a snapshot regarding the scope of the NSF using the number. Budget-wise, last fiscal year, we have about $8 billion. And we have evaluated about 50,000 proposals. And among those, 12,000 being awarded. So it's about 25% in terms of funding rate. And the institute, college, university being supported by NSF is about 2,000. And there are almost 400,000 people, PI, graduate student, postdoc, special senior personnel, etc., are supported by NSF grants. And as I mentioned there, one thing we also want to make sure is that the education is nicely integrated into the research. So we have spent about a little bit over $1 billion on the what's called the STEM education. And NSF also involved a little bit in terms of the small business funding through the SBIR, STTR program, $200 million from last year. So next slide, please. So this is an org chart of NSF. Under the director, deputy director, there are seven directories that do research. And so among those, engineering directorate, where I belong, is probably one of the active one, and strong one, supporting a lot of additive manufacturing research as well as the general advanced manufacturing research. But apart from that, there are other directorates. They also have some programs supporting additive manufacturing. For example, the computer information science engineering, the math physics science, as well as education human resource, EHR, and they provide funding for education as well as workforce development. And in the director, deputy director, underneath the office, there are also the Office of International Science of Engineering and Office of Integrated Activity. They also have programs that have supported additive manufacturing research before, which I'll show a few examples later on. So next slide, please. So in directory of engineering, there are 5 divisions: engineering education and centers, chemical, bioengineering, environmental, and transport system. This is what's called the CMMI, Civil Mechanical Manufacturing Innovation, where I belong. And also electrical, communication, and cyber system, industry, innovation, and partnership deal with SBIR, those kind of program. So advanced manufacturing cluster is inside the CMMI. And in addition to advanced manufacturing, we have other 4 clusters. dynamic control, and cognition, mechanics, engineering, material, and operation and engineer and design, and resilient and sustainable infrastructure. Next slide, please. So using this slide to briefly talk about the evolution of advanced manufacturing program. In the old time, we had different programs related to advanced manufacturing, but sometime in 2018, NSF issued a dear colleague letter indicating the consolidation of all a couple of manufacturing related programs to what's called now the advanced manufacturing program. So in the old time, we had manufacturing machine and equipment, material processing, manufacturing, tribology, materials engineering, and along the time, some kind of new area emerged. For example, nano manufacturing has been a strong one and continue to be strong. But one of the reasons that we kind of merged them together as just one cluster program is try to remove the boundary between those sub-programs. Because sometimes the proposal or the project, they are not just reached to one program. It may kind of cross-cutting or reach multiple programs. So the advantage is that we can take a better view on that. In addition, it also provides a broader perspective that allow us to collaboratively work with other programs across the agency that are looking into some new tools, new knowledge that we can further accelerate the advances in manufacturing. For example, artificial intelligence, big data, machine learning, biomedical manufacturing, they are all pretty new. And so consolidating all the manufacturing program is hoping that we can have a better chance, a greater way to tackle those challenging problems. So as of now, we, including myself, we have 5 program directors, a very nice group to work together, work on this. Next slide, please. So a busy slide, but just want to show you, give you a flavor about the portfolio of the advanced manufacturing program. So you see those are keyword analysis showing up in front of the award that what show up more frequently. Nano manufacturing has been a strong one. There's a lot of interest in the small scale device system behavior, and they are quite different from large scale. And we also discuss a lot of new things that can be used for innovation. So that has been a strong area. But as you can also see, additive manufacturing is like printing, metal, and they are also a pretty impressive large portion. So we support all different kind of manufacturing technology processing, ranging from traditional machining and up to the new, say, emerging technology related to, say, digital twin, as well as industry of 4.0, those kind of things. And material-wise, obviously, of course, the whole spectrum. You have metal, metallic, alloy, and ceramic, polymer, as well as intermetallic, and carbon nanotube, and you name it, a lot of different things, and also across different length scale, going from nanoscale up to a macro scale. So very large portfolio. So next slide, please. Another busy slide, but I want to use this just to talk about the NSF engagement in additive manufacturing research. So let's start with National Additive Manufacturing Innovation Institute, the first Manufacturing USA Institute that was established in 2012. And in 2013, it was rebranded to America Makes up to now, already 7 years. So it has been a very successful operating model for the Manufacturing Innovation Institute. And right before that, before 2010, NSF sponsored a workshop to look into the future of additive manufacturing. It's called Raw Mapping. So it was organized by Dave Barov, Min Lu, David Watson. I hope I didn't leave out anyone. But they issued a report 2009. It provided very nice in terms of what kind of research, especially fundamental research, will be needed to further advance additive manufacturing. And as you are also aware, in 2009, ASTM formed the F42 Additive Manufacturing Committee. And so a lot of standard terminology have been set from there. So it's also a very good milestone. And around in early 2000, NSF asked the Institute for Defense Analysis to conduct a study to look into federal agency, not just NSF, but DOD and other agencies as well, to kind of examine what is the role of federal government funding support to the additive manufacturing development technology as well as the industry. So the report was released in 2013. It provides a lot of insight about this additive manufacturing movement. In 2013, I think NAE sponsored a workshop looking into the predictive model computational for the additive manufacturing. It was also sponsored by National Science Foundation. And in the end of 2014, if you remember, the REMI Act, Revitalize American Manufacturing and Innovation, was signed into the law in the end of 2014. So the National Network of Manufacturing Innovation officially took off. And then in 2016, they got rebranded to what's called now Manufacturing USA. And right after that, NSF issued a year-quarterly letter trying to encourage basic research that will enable the advances in terms of research being conducted in the Manufacturing Innovation Institute. And also around 2016 or 17, NSF sponsored another workshop trying to figure out how you can take the NSF fundamental research and transform that into the additive manufacturing application for the industry. And a couple of universities organized that, and including, as you can see, America May is also part of organizing team. So very successful. So take you back to before 1990. As I say, NSF has supported continuously on additive manufacturing research, but there are two awards very significant in the late 80s. So one, as you can see on the slide, around 1987, there was an award related to selected laser sintering to UT Austin Joe Beeman, which later they issue a patent. And the other one is award to MIT, Emmanuel Sachs, that eventually later had a patent in binder jetting process. So these two, according to the IDA study, have a huge impact to the advances in additive manufacturing technology development. And now, of course, even before 1980s, NSF founded project in the area of computer-aided design, computer-aided manufacturing, as well as computer numerical control. They all form a kind of good backbone for the additive manufacturing. So can we go to the next slide, please? So here's a kind of quick snapshot regarding the IDA study that I mentioned in the previous slide. So again, NSF asked IDA to conduct a study trying to look into the role of the National Science Foundation in the origin and evolution of additive manufacturing in the United States. It's in the public domain, and I have a link there that you can take a look. And I think my PDF will be shared as well. So if you have not seen this report, I strongly encourage to check into that. It's about like 150 or 200 pages, but you can just read the exact summary, or they have actually shorter paper to provide a very concise conclusion summary of what they observed. So a quick information is that they look at from 1986 to 2012, NSF actually issued around 600 awards in the in the area of additive manufacturing. And dollar-wise, I think it's about 200 million based on the 2005 dollar value. So it's a huge investment, and we support research in all different additive manufacturing technology, powder bed fusion, material extrusion, chip lamination, which I'll share some example with you later on. And they actually also talk about what like fundamental research area that would be ideal for NSF to provide support. And obviously, it's all very fundamental. So it includes material development, look into material property improvement, look at the fundamental science that dealing with the processing of additive manufacturing, and related to the production speed as well as the quality resolution. Control, the closed-loop feedback control had been supported as well. And actually, the hybrid process, additive subtractive processes have been mentioned as well, and also bioapplication, and also getting to the nano domain. So next slide, please. So I briefly mentioned in the NSF org chart regarding what directory they support additive manufacturing. So using this slide, go a little bit deep dive. And so in engineering directory, which provide probably most support to the additive manufacturing. In our division, civil mechanical manufacturing innovation division, in advanced manufacturing program, this is probably the biggest one that provide the most additive manufacturing research support. But that's not the only one. We also have a program cluster in mechanics of material structure engineering for civil infrastructure, as well as engineering and system design. They all have some support to the proposal in the area of additive manufacturing. Other than our division in engineering, the CBAC, the IIP, as well as the electrical computing communication system division, they also have a different program that provide additive manufacturing research. For example, in CBAC, I'm familiar with the thermal transport processes. And in IIP, I think most people know the SBIR, STTR program, and they support the research in additive manufacturing as well. Now, in the math, physical science directory, we have a material research division. So they have a program in polymer, metals, metallic, nanostructure, as well as ceramic that are interesting in the material aspect in the additive manufacturing. So they have provided support as well. And now in computer information science and engineering, and they have a couple divisions that have support in additive manufacturing. For example, the cyber physical system in the computer network system, they have that. And in the information intelligence system, they have National Robotic Initiative 2.0 that has found some additive manufacturing research as well. And then you have the educational human resource, as well as others. So can we go to next slide? Next slide, please. Okay, in terms of funding mechanism, actually, can you go back to funding mechanism slide, please? So in our core program, or we call unsolicited, so you can submit proposal anytime you want. We don't have deadline. So typically, this can be just a single PI or even a small collaborative team, whether it's inside one institution or a different institution. In general, it's about 2 to 4 year period of performance. Budget-wise, 300 to 500K. We don't really set the budget. We want PI to justify the need. So we have even seen like 700 or 800K. It's really about the justification. And some of you may know that the industry can participate in this as a partner. There's a Goldie program, grant opportunity for academic liaison industry. So in the sense, it's academic working with an industry partner to identify the fundamental research that cannot be done in industry, but university can do that. And that fundamental research has a potential to be transformed into the applied R&D for industry to utilize. There's also a different solicitation. For example, last year, November, I think, we issued a future manufacturing program. And also I mentioned right after Manufacturing USA was rebranded, we issued a Manufacturing USA Dear Colleague letter to encourage people doing the basic research related to those manufacturing institutes. And there's also earlier career call that is designed especially for junior faculty that not just work on research, but also integrate education and research together for their career planning. And there's also a solicitation for the minority serving institution most focused on the primary, the undergraduate program. And they also major research instrumentation research center like ERC, that kind of solicitation. And they also international collaboration. I know particularly in the advanced manufacturing, we have a kind of joint call with German DFG to encourage the collaboration between the two sides. And in the engineering directory, we also have a collaboration with the UK kind of research institute to encourage the collaboration. And I'll also show you some workforce development project. And we also support workshop if people interested in trying to identify like role mapping or what is the research need for particular or general additive manufacturing. That will be considered as well. And we also support quite a lot of student conference travel engagement as well as student competition. Next slide, please. I believe I have very short time left, so I'm gonna go super fast, and hopefully I can get through a few. And so next slide, please. I wanna show you a few exciting projects that I'm very proud to talk about. And so the first one is regarding the powder bed fusion process. As you know that due to the rapid heating, cooling repeated, you have high residual stress that will be as bad as that can cause the part get delaminated. So you gotta put a support structure. So what this team does from University of Pittsburgh, led by Professor Albert too, they work with a company, so this is a Goldie project, come up with some kind of new idea in terms of dealing with the strain and incorporate that into their design mechanism. So as you can see in the lower right corner, that figure showing you how to design the part or arrange the part so that you can optimize your support structure so you don't have the fan. So next slide, please. So this is about the biojetting process, dealing with the ceramic part, ceramic powder used for like joint prosthetics, ballistic armor. So the problem they identify is that if you use like a bigger particle, a micro powder, usually you have very low sintability, even the flow rate is better. Now, if you switch to a smaller particle size range, like nano powder, their flowability is become low, even though the sintability, because particle size is smaller, is higher, but the nanoparticle, they tend to get agglomerated together, so it's hard to flow. So they study how if you can add some granule on the micro powder. So on one hand, you can increase the flowability, and on the other hand, you also enhance the sintability. Next, please. Next slide, please. Here's another Goldie project. from Virginia Tech. The process they deal with is they call fused filament fabrication, but as you know, this is a material extrusion shredder process. And the problem they try to solve is regarding the part quality consistency. So they implemented a lot of sensor, as you can see here. There's an ion, there's a camera, visible camera, there's a vibration. So they do what's called a heterogeneous sensing. And then with lots of data, they use a data analysis technique to come up with some kind of algorithm that they can have some closed loop control to reduce the defect or find a way to mitigate the defect. Next slide, please. Here's a project related to bioprinting, and it's also one of them in response to the Manufacturing USA DLC. So what they try to do is to do the self-supporting, what's called a nanoclay. Basically, that through the process, your material state, going from the shear state and through the transition state, and then in the end, it becomes cross-linked, so it will kind of become self-supporting, so you can print it without the support structure. So they use this for tissue engineering, neural chamber with the cell. Next, please. This one also deals with metal additive manufacturing. I believe initially it's a powder-based process, but they got evolved to the hybrid process. So again, it's like a problem that a lot of people are interested in that, trying to tackle that. You have the defect, you sense that, and how do you find a way to control that or mitigate that? And so they have a different mechanism to correct the defect using rescanning or using a subtractive method to even remove the delamination. And on the other hand, they develop some kind of quick computational way using what's called the graphic theory, so you can look into the temperature evolution as you build the part. Pretty neat. So next slide, please. I think I'm going out of time, so can we just jump a few slides? Go to the slide that has the title NSF and American Leadership in Advanced Manufacturing. So I apologize that I was not able to show to describe every single event, but again, they are on my slide, which will be shared with the attendee. So let me just talk about, in the end, the previous slide, please. So a couple of weeks ago, Manufacturing Day, October 2nd, so NSF announced the award for the future of manufacturing and also trying to be firm in terms of our position in supporting the advanced manufacturing. So as you can see from the fact sheet mentioned, in 1980s, we already provide a lot of support in terms of fundamental technique for additive manufacturing. And the annual investment in additive manufacturing by NSF is about 250 million. And so that's pretty impressive. So let's go to the next slide. I just want to highlight, we made about 24 awards for future manufacturing code, and there are 4 that are related to additive manufacturing, which I want to share with you. And they are on the public domain, so if you go to the NSF award search site, you can find this. Future manufacturing is like you need to have a vision seeing what future, how the manufacturing will be done in the future, to be ready for the industry of the future. So go to the next slide. I believe I am over time, so I'm not sure whether I have time to take the question. But if you have any question or you are interested in proposal submission or any other question, please feel free to send an email. We have a general email address that everyone is looking at in our program. advanced manufacturing at nsf.gov. Thanks for your attention.
This is just the summary of, hey, please get engaged. Do you want to have an impact? I think I've hit that kind of slide by slide, so I'll stop talking at this point and hand it back over to Brandon. But if you have any questions, if you want to get more engaged, reach out to me, reach out to anyone you saw on the slides, reach out to Brandon. We're really excited about what we're doing here as an RMAG and a working group going forward. And we're going to need your help. We're going to need your voice to make this relevant and to make this impactful for the community here. So with that, I'll get off the stage. Brandon, over to you. Thanks for the time and apologies for going over.
Thank you, Brian. A very important discussion to have. So again, please reach out to myself, Brian, any member of the RMAG to get engaged. There's a number of questions. I think a great way to address those for those who ask those, get in touch with us. We're happy to talk to you. And yeah, thank you so much, Brian. It's really great to be able to share all this good information and see all this progress. At this point, I'll welcome John Lozinski to the stage so he can introduce our next speaker.
Hello, everyone, again. So very excited to bring the next speaker up to the stage here virtually. Dr. Beth Ripley is someone who I didn't know in early March, and I feel like I know very well now 6 months later, as we've spent many, many, many days together over the past 6 months. So very excited to have Dr. Ripley on to share a message about where VA is going and what you're doing to kind of introduce and incorporate advanced manufacturing into the VHA system.
Excellent. Thank you for having me. Hopefully you can see the slides okay. And we will just dive right in. And so today I'm going to tell a story about VHA and 3D printing, kind of where we started on this journey, what we're up to now, and where we hope to go soon in the future. I like this near term and now term, so we will try to kind of mix that in. So this is just the crib notes, what we're going to go over. I'm going to talk about the evolution of 3D printing at VHA. One of the really important things I hope you see through this story is the importance of the public-private partnerships that we've made in our growth. Each time that we make a new partnership, we seem to exponentially speed towards growth and maturation of our system, and we hope to continue that. And then really now with COVID, we are getting down and dirty about what does point of care manufacturing really mean. And we might try to unpack a little bit of that. So of course, every story told by a radiologist begins in a dark room. But actually, it's not my story. It's the VA story, and it started way before I got there. So we have to go back to 2010. And part of the theme here is I'm going to have the time stamp in the bottom. And some of these slides are actual authentic old slides that I pulled from decks. But this is where VA was in 2010. You can see that they are an early adopter of 3D printing. This is Richmond VA turning out all kinds of assistive technology items. And so these are items that they've designed for each and every veteran to help them interact better with their environment. A few of my favorites down here, this is the makeup brush adapter. This was for a veteran who had tremors. It was very difficult for her to hold on to things like makeup brushes. And this was a simple but ingenious solution that hooks over her hand, holds the brush in just the right angle, and allowed her to apply her own makeup. Along the same themes over here is a pool cue adapter that was made for this veteran who experienced some traumatic brain injury and lost a lot of control over his arms. Now he was an expert pool player before his injury and he wanted to get back to that. So they designed this little roller that got him back to shooting pool. Also, neck and neck, they compete, Richmond and Minneapolis, about who was first. But at the same time, 2010, over in Minneapolis, this is Steve Morin. He was working with a group called MADE to design instruments and other types of widgets. One of my favorites is that finger-looking thing that says MADE. And that is actually modeled after a resident's hand. So If any of you are in medicine or watch shows, you know that the residents always get hazed in surgery. And so they actually would have a resident come and scrub into every one of these surgeries just to stand there and hold their hand out so that they could keep all the cords from the surgeon's equipment off the sterile field. And so that resident would stand there, you know, for 10 or 12 hours. And that's just sort of a badge of honor for residents. But Steve here felt mercy, so he designed this solution here that saved residents everywhere. So this is a finger adapter pretty much to hold those cords off. In 2017, this is when I came to the VA, and I brought with me as a radiologist the interest in pre-surgical planning models. So these are the first few that we kicked off at 2017 in Puget Sound. One of these, the one in the bottom right-hand corner, was made in a friend's basement off his printer. It's a Formlabs printer. I painted this with my daughter's paint. You can actually see a theme of me painting in the early days. Not beautiful, but functional, and that's how we kind of got it done. Really, though, I think the most important thing is that we all met each other and we started talking, and we got this kind of harebrained idea that we should all just string together. Even though we were doing different things, widgets, tools, assistive tech, kidneys, etc., you know, we all had printers, we all had common problems, and we all worked in the VA. So we imagined this idea of the National 3D Printing Network, and this is the actual slide from when I presented it. And I'm happy to see that we're not totally off. So, you know, our goals here were integrating resources, building technical expertise, creating SOPs to ensure quality and safety, and quantifying value. Now, there's a lot still to be done off that list 4 years later, but that was the vision. And this is where one of the first partnerships we had really kicked us off. So we partnered with Stratasys to build out this network, and they donated 5 printers that we placed in VAs sort of strategically across the country. So those are the 5 stars you can see: Seattle, Albuquerque, San Antonio, Orlando, and Boston, adding to our existing sites of Richmond and Minneapolis. And at that point, we had some expertise in New Orleans, but we grew, and we got some buy-in from the leadership and started to move forward. This was kind of the concept, you know, this is Seattle to Orlando. I knew how to segment data at that time. Orlando had cases and printers, so we were trying to explore how they could send their images up to Seattle so I could segment them, I could send them back to Orlando and print. So we were working on that, but it also exposed one of our challenges, which is that it's hard to make some of these models. And, you know, we're trying to learn all the different softwares, and we started a partnership with GE Healthcare to look at how they could adapt radiology specific tools to enable better and faster 3D printing. Back in 2018, we also started thinking about quality and safety, but this was our version. Remember, we're still in the hospital. We don't have manufacturing friends yet, and so we're doing it the old-fashioned way. We had cadaveric hearts and other tissues that we would CT scan and then print out and then try to measure, just to try to understand what the limits of the technologies were. And we continued to grow. And by 2019, we had 34 hospitals across the VA with 3D printing, in large part funded by our innovation program, which put significant resources towards this, as well as top cover all the way to the top of VHA with some executive sponsorship, which was really critical for us. And we also started to cross-pollinate those capabilities. So I had mentioned assistive technology, we had pre-surgical planning, we had a budding orthotics and prosthetics group, and of course dental had been around for a while too and was growing. And so each one of those 34 sites started to adopt more than one of these technologies, and they just, again, started spreading back and forth so that we had them popping up at multiple hospitals. And that was really fast-tracked by this advisory committee that we had set up back in 2017. And we, I call it the Noah's Ark. We took somebody from every, you know, walk of life. We had patient safety, we had surgery, radiology, we had IT, we had logistics, we basically somebody from each of the major groups. And I also want to point out, I don't know if you can see my cursor, probably not, but Megan McCarthy is in the corner here. She's from NIH. And then also Matthew DePrima and James Coburn from FDA are at the table as well. So we had partnered across the agencies at this point in the advisory committee. And this was to think about large-scale infrastructure. How do we bring together networks? How do we move across hospitals? How do we share resources? As we got into that, we then thought, you know, we should really not just stop at the walls of VHA, and we should go to DoD as well. And so we had a joint incentive fund funded where we decided that we were going to try to build out a quality management system that went across both VA and DoD, and we wanted to register with the FDA to make 1 or 2 items off of titanium printers. And we also wanted to think about training programs for staff. So we were really excited at the very end of 2019 for this to be awarded. And this was going to be our next trajectory. And then of course, COVID-19 hits and everything changes. And our first focus really was this shortage of PPE endangering healthcare workers. And we all had friends and colleagues at New York at this time, this is March 3rd, that we were really worried about. And so we went into the hospital to see what we could do. Of course, you know, 3D printing didn't make sense quite at the beginning here, but we thought we would give it a try. This is one of our first forays. This is the stopgap face mask that we made. And so you can see on March 22nd, I think that was like a Saturday, we decided to go in, we scanned Chris Richburg's face, he's here. We started trying to think about what to do. Our first prototype, March 23rd, pretty rudimentary looking. There's a rubber band involved here, but it was a start, and we just kept iterating. So March 24th, you can see by March 26th, we had some surgeons and other end users coming in to give us feedback. March 27th, we did a bunch of fit testing. And then our printers went down for a few days because, you know, we were pushing them beyond where we had taken them before. And, you know, that's just always what happens, but set us back a few days, but we got back on track. And by April 1st, we had our first design. So this is the first iteration. Right around this exact same time, we formed a really important partnership between FDA, NIH, VA, and America Makes with the goal of sorting through all of the incredible swell of ideas that were out there at that time, from face shields to face masks to ventilator parts. We wanted to come together and try to figure out a way to curate those and provide the safest and best solutions out to the general public. So we did that through interagency MOUs and collaborative research agreements, and created this COVID-19 3D printing rapid response team. And we hosted designs on NIH, VA tested the designs, FDA provided guidance and review, and America Makes played the role of matchmaker, so connecting those who needed products with those who could make them. And, you know, these numbers keep evolving, but this is where we were at maybe a week or two ago, with almost 750,000 unique site visitors, 611 published designs, 1.36 million total views. And one thing I really love about this is you can see it's not just in the US. This was worldwide. Meanwhile, again, in VA, we start to grow again. And we went from 34 sites to 61 sites since COVID. And so these are all of the sites. I can't even make this into a nice graph yet because this data is just hot off the press, but we've got 61 sites here, several of them with just one type of printer, which is what the small dots are, several of them with many types of printers at this point, continuing to grow. We've got 176 printers within the system, and that number is counting, and they're not all the same type. You can see we do have a few of certain technologies or vendors that are larger here, but we have multiple different types of printers within the system. And when you step back and think about where we've come in the past few years, really, you know, this is looking a lot like a hockey stick, I think, with some exponential growth, and we will see where we go next. But meanwhile, we do have some ideas, and this is going towards the future. We have set up the capability to work together across a few sites that we're kind of locking down to start to build out a comprehensive quality management system. We did just register our first VA hospital with FDA last week. We are putting finishing touches on a really, you know, down and dirty quality management system that gets us up and running as we figure this all out. And we are breaking ground within hospitals, in 3 hospitals, to build out infrastructure. So this is in the basement of our hospital in Seattle. The really significant thing here is that hospital real estate is like gold, and we've gotten 6,000 square feet, albeit in the basement, but as a radiologist, I like the basement, so I have no problem with this. But so we're moving in here. We're not waiting to paint the ceilings, you know, or the floors. We're just getting printers in here and trying to get up and running. And, you know, I know that we were a little behind on time, so I tried to kind of cruise through here, because I think the really interesting part of this is, where are we going next, right? So we have linked some hospitals, we have top cover, we have groundswell of interest, we have mini printers, and we have an immediate, like, what are we doing right now plan, which is to try to buttress our supply chains as needed and also share those solutions out. But we really want to focus on the near term next and the long term next. And that's really about making it right. Like, how do we do this? What does this point of care manufacturing look like? I think I had no clue how onerous, like, OQ could be, until we're just printing and printing and printing for weeks on end just to try to, you know, test printers. These are some of the things we just, you know, probably didn't grasp early on. But we do have some new partnerships that are very important in this as well. You know, notably with the mask, the first mask, we had a partnership with 3D Systems. And then we have a play to try to bring that into N95 world, and that was a partnership with the Barnes Group and Associates, or actually I think it's the Global Associates now, TGBA. We have obviously our new partnership with America Makes, as well as governmental partnerships. And we want to just keep on growing, and our goal here is to be a test bed for this concept of both public-private partnerships and how we work together, but also really trying to unpack what is truly involved in point-of-care manufacturing and what makes sense and what doesn't. In going fast, I think I missed telling you one important thing that I do want to be a takeaway beyond, you know, the growth in VA, our eagerness to understand this situation and grow it, which is, why are we even bothering to make it in the hospital? Why don't we just find somebody else to make it? And this is a tough question, and, you know, there's a lot of different answers and people feel differently, but I will tell you why we believe this is important. It really came down to the mask case, where we could see how fast we could iterate when we had the surgeons, the end users, in-house right next to us, and we could just run prototypes over daily, throw them on them, see what they say, pull them off, run back to the printer, and hit go again. Also, in terms of testing and efficacy, we had all of our safety team right embedded with us. And it just allowed us to work so much faster, and I think get down to, you know, the chase of what we were trying to do. So that design and development and testing component in the hospital, I think, is a very valuable component that we wouldn't want to lose. Whether or not manufacturing happens in the hospital or then translates back out, you know, who knows? Something to figure out. But again, I will stop there because I know I had till noon, and I see 11:57, and I want to be able to answer questions if I can.
You can, and you have time. So
all right.
Thank you so much. 2 questions that came in. First is around something you just hit on a little bit. So how do you control the quality of the products you 3D print? Does FDA have requirements and methods to assure quality? So I know you hit on that a little bit. Maybe you can talk a little bit more about what that means to you in the hospital.
Absolutely. So there's a lot of confusion and just exploration still, I think, about what it means when you're making in the hospital. And, you know, I think the bottom line, well, there's black and white on 2 sides, and then there's a lot of gray in between. So if we're talking about one patient and one doctor, and that doctor is making something specifically for his or her patient, and, you know, kind of the safety of that is known, that could be construed as under the practice of medicine. And, you know, that's just between the doctor and the patient. The other extreme is you're a hospital and you're putting out like thousands or hundreds of thousands of these things and selling them. Well, you're not a hospital at that point. You are clearly a manufacturer, and you thus need to do exactly what the FDA says. And then you could start to argue these kind of like gray areas in between. But our take on this is that the FDA regulations are there to ensure quality and safety of the product. So we pretty much feel like the second you take away from that first black and white, like just what's going on between one patient and one doctor, that's when we need to really start thinking about and adopting the concept and the idea and the real. We are no longer a hospital. We are a manufacturer at that point, and thus we need to obey all the same rules and regulations as anyone else. And that's where the quality management system, you know, registration, just, you know, again, luckily I'm not the regulatory person, but I've seen enough to know the pain. And so, you know, we're learning that, and it's going to be hard, and some of it we're going to fail at, and some of it we're going to be able to do. But what we again want to do is really be a sandbox for people to think about this. So we're going to be really open and honest. What you're going to be seeing from us over the next several years, hopefully, is us talking about the growing pains, what we've learned, what's gone right and what's gone wrong, so that other hospitals kind of know what they might be getting into.
Good deal. Last question. So, you know, CT data is very common for you, and having access to that. Do you have technologies that transfer scan data readily over to AM or additive manufacturing files, so you can, you know, very quickly and easily make, you know, reproduce, whether it's implants, a, you know, growth, a surgical aid, whatever it might be? How do those 2 technologies work together in your world?
It's a really important question. There are several softwares out there, growing number. I won't go through all the manufacturing names because as government, I don't necessarily want to do all of that in case it's, you know, seen as an endorsement. But I think many people, if you Google and look for segmentation software, you're going to find a few industry giants that are coming traditionally out of the AM space. You're going to find a few emerging players coming out of the imaging space, and then something in between. The bottom line is it's challenging. It's variably challenging to change some of the imaging data into models, it requires some level of understanding of the physics of imaging and also anatomy. And the holy grail is that that is all done by AI or in an automated way. And there are, so same thing, if you look at some of the major manufacturers, either in the AM space or the imaging space, you'll see that some do have segmentation software solutions that are automated, which is fantastic. And from a QMS perspective, if it's locked down, that's great. The problems come when you have noise in your data, aberrant anatomy, or something else that's off. So you have to be careful. I think for us, it's worrisome to just depend on that, because you're going to find a lot of errors depending on what your population looks like. And so, you know, I think that we'll see a lot of growth in this area. I think that will unlock a lot for people. I don't think that we're 100% there yet. And again, very long-winded answer from me, but kind of a challenging question.
Yeah, we're full of them. You should hang out with us a bit.
Yeah.
Thank you so much. Been a pleasure working with you over the months and continue to work with your team. I think that was helpful for everyone. You know, we haven't had a lot of that perspective over the last couple of years. So appreciate your willingness to jump on here and get involved with us. So thank you much, Beth.
Absolutely. Looking forward to collaborating with everyone in the future too.
Good deal. So we're going to take a break now. So this is a 30-minute scheduled break, or we'll actually schedule it for 26 minutes. We'll come back on at 3:30 Eastern, and we'll start back up with a outbrief from a workshop that was held this past summer by Greg Kilchenstein out of the Office of Secretary of Defense. So we've been working on getting him here for the last couple of years, and this year being virtual, we were able to make it all work out. So encourage you to come back here in 26 minutes, and in the meantime, we'll have the networking open. So please enjoy that. Thanks. Hello, everyone. Welcome back. So we're ready to get the final portion of the day kicked off. So as I mentioned, going into break, you know, we work closely with the Department of Defense in a variety of different ways. And Greg Kilchenstein has been a huge advocate for AM over the years. And we together, you know, between work he's doing in projects he oversees, as well as some things that we're doing, Greg at America Makes, have been working on this thing. This year, the term is AM Workshop. This has about 5 different names, I think, in 5 years. But it is a fantastic event, and this year was no different. So we've tried for the last couple of years to get Greg and get schedules to work out, and it's always been tough with travel. And this year we got him because, you know, I don't know if he had to leave his house today or not, but we got him virtually, so that's good news. So I'd like to introduce Greg Kilchenstein. He's going to give an overview and outbrief from what happened this summer at the AM Workshop.
Yeah, it's good. So good afternoon, everybody, and thanks, John. Thanks for America Makes for this invitation and this opportunity today to share with you. Let's see how my remote training went here. I'm going to try to share my screen with you, and it's not doing it. My screen or not. I am gonna. Can you see the slides now?
No, we can't, Gregory. I can share your screen for you.
One quick thing there.
Enterprise Maintenance Technology in the Office of the Deputy Assistant Secretary of Defense. Material ready.
Hey, Greg.
I wear many hats. Where is I chair the Additive Manufacturing Operations Working Group. This group was chartered very early on in the process because we knew we needed for the DoD and industry in order to scale additive manufacturing across an enterprise the size of the DoD. And it looks like it's loading up my slides here. John, can you hear me?
Yes, Greg, I can hear you. You're kind of fuzzy. So Andera is going to share your slide. Yeah, I
can't hear anything at this point, and I don't know if I'm talking to myself or I'm talking to the 180 people or thereabouts that are online right now.
Can you hear me, Gregory?
I can hear you, Andera.
Okay. Let me just give this another second. And can you hear me now?
We can.
Back out here.
Andera, can you hear me?
I can hear you.
Okay.
Just cancel this.
Texting maybe.
Tara, if you could load my up, that would be fantastic. Say you right. I just think I did.
Yeah, can you try again, Greg?
My remote training wasn't all that good, so
We're talking to Greg offline, so hopefully we can get him to refresh and come back without a camera. So after all the buildup of a couple of years of having him come, hopefully we can get him on the stage. I would prefer that he brief these versus somebody else try to, but we'll give it a minute here. Please hang tight, all. In the meantime, just to fill a little bit of a void, I wanted to.
Am I back, John?
Yes, sir.
Okay, so having a hard time sharing slides on my screen. So if Tara or somebody could load those, that would be fantastic.
Yep, they are. We see them now, Greg.
They are? Okay, perfect. Perfect. So again, I don't know how much you heard. I was talking to myself, I think, for a while. I'm Greg Kirchenstein. I apologize for the 6 minutes of dead air. I'm the Director of Enterprise Maintenance Technology in OSD Material Readiness, and I chair the Additive Manufacturing for Maintenance Operations Working Group. Next slide says, I'm going to give an overview today of what we did in the 2019 Additive Manufacturing Workshop back in June, between the 23rd, actually went to the 25th of June for the outbriefs. We started these John says they changed names, and they have. We started off as word games back in the 2015, 2016 timeframe. We did word games. We identified the challenges in those word games, and from 2017 to present, those gaps and those challenges in these widely across OSD, the Department of Defense, academia, and with industry across the board. The purpose is collaboration. We work better together, so this is an opportunity for us to get together and work around these challenges that we all face. Whether you're a DoD person or you're a person from industry, we all face the same kinds of challenges. It was organized by and executed really by the trifecta, and the trifecta was the Additive Manufacturing for Maintenance that I chair, manufacturing working group that Tracy for, and then the Additive Manufacturing Maintenance and Sustainment Working Group from American Makes. Slide, please. So I'm going to give a little bit of an overview of the 2020 workshop. It took us the better part of 9 months to organize, 3 days to execute, and I'm going to try to get this thing done in about the next 18 minutes. So I have time for questions and answers. So it'll be an extreme challenge for that. A little bit about the demographics. This year we had more registrants and more participants than ever before. I think we did it virtually, and because we did it virtually, folks didn't have to travel, and we were able to get more folks involved in this thing. We organized around 6 functional disciplines in life cycle: legal, logistics, program management, engineering, contracts, and enterprise level IT. And you see the demographics here. We were very, very heavy on industry participants, which indicates to me that we in DoD and those of you in industry we all share the same challenges with trying to scale additive manufacturing across our enterprises. We organized in 7 distinct working groups with between 20 and 50 members in each working group to attack these challenges that continue how we are scaling additive manufacturing across the DoD. Slide, please. So I'll go a little bit into the working groups at this point. Getting together with the Joint Additive Manufacturing Working Group and America Makes Maintenance and Sustainment Advisory Group, we selected 7 working groups based on what we believe are the most pressing challenges for us at this moment. The cyber challenge is always with us. Additive manufacturing data management is another area that we consider a big challenge, and how we share that information widely across the Department of Defense and with industry. We are in the process right now of issuing new additive manufacturing policy that covers the whole entire life cycle of additive manufacturing, from early design through acquisition and all the way out into sustainment and retirement. So vastly expanding the directive type memorandum, and on the heels of that policy, we're going to need some detailed guidance for what we mean in those broad policy statements. So we're working on framing a new additive manufacturing guidebook. Slide, please. Workforce development. This is one area. This is our 3rd year of working the workforce development piece. We all know that the tools and the technologies are great, but the people have to understand the value of those, how to use and how to apply those tools and capabilities to make additive real. Additive metrics are another area that we took on this year for the first time. We continuously get questions, not only from our own department, but from Congress, in terms of what are we doing with additive manufacturing and how goes it in our department. So looking really deeply then into how we set up those metrics and then how we report those metrics are another area that we addressed this year. The whole additive manufacturing risk categorization. Part risk categorization is absolutely foundational and critical to what we're doing with joint additive manufacturing acceptability initiative that we've got going on right now. We need a common way for us to categorize risk for additive manufacturing. And then if we're gonna share information across the Department of Defense and we're gonna work in unison with industry, then we need a common DoD additive manufacturing tech data package for that as well. So they're really the 7 areas that we focused on. And if you go to the next slide, what I'm going to do now is I'm going to dive a little bit into each one of the working groups. And the first one was the cyber challenges. We had 2 sub-working groups within the cyber challenges. We were looking hard at industrial control systems and the overlay therein. The co-leads for that were Stephen Richard and Kevin Winters for that one. And then the other piece really then was how to encourage additive manufacturing machine manufacturers, the cybersecurity. So when we partner with industry on this, we're all talking about the same kinds of things, and how can we just open the box up and have better cyber controls for the additive machines that we put in place, and then ultimately we want to connect to our networks. Next slide, please. So some of the key highlights from this really important working group. Again, we can't talk about additive manufacturing at scale in the department without running headlong into the cybersecurity challenges that it poses to us. So advancing the manufacturing networks and industrial control systems is key. To date, we have very few additive manufacturing machines across our vast enterprise in DoD that are actually connected to the network. We are still relying on SneakerNet to literally provide the kinds of controls that we need and the cybersecurity we need to make sure that either the data itself can't be tampered with or it can't be extracted and used by folks without those permissions. So that was an area that they dove deeply into, and they've come up with some recommendations for that. And again, this is an active working group also that meets well outside of just a workshop that we do on an annual basis. These folks get together on a monthly basis, and they're continuing to tackle these challenges. They're working hard to consider both the physical and the process monitoring as a substitute for continuous monitoring of additive manufacturing cyber. So we can't substitute thoroughness of our cyber controls for speed, but we can look at taking a different approach to additive manufacturing security, and that's what these folks are doing in this area here. Additive manufacturing software as a service was brought up as a way for us to help control how our hardware and our information systems interact with one another. And then cybersecurity assessors. We must have basically a different way to do cybersecurity controls. We can't have a cookie cutter approach for everything that we do in our IT world, that we really need to treat separately, distinctly differently than other IT capabilities and take a tailored risk-based approach to additive manufacturing. So this is where our cyber group is focusing their attention at this point. So moving on to now the data management piece of this. If we're going to share information widely across the Department of Defense, and we're going to work collaboratively with industry and show one face to industry from an additive perspective, then we need to develop a common language for how we represent additive manufacturing data to ourselves and with industry. So at this point, the objectives of this group were to mature the additive manufacturing data standards and our additive manufacturing data definitions. So this is another group that's been a couple of 3 years on doing this, and they continue to move this ball down the field on a monthly basis. They also want to explore how we can best share that pedigree data and the materials and engineering data required for us to share widely across our Department of Defense. Next slide, please. So this group basically had two sub-working groups. One still working continuously on this common data dictionary, and now another group led by Mark Benedict. This was a first for this year. That really was going and taking a deep dive into what we call the Common Additive Manufacturing Data Experiment, Camden. So this is not only what we share, but how we would share that information widely in the Department of Defense. Next slide, please. And this one, I apologize, it's a bit of an eye chart, right? But when we start talking about data and data sharing, the first thing that pops into your mind is kind of data. What is the data that we're talking about? And it's really the data that's across the top of this particular slide. The parts selection data, design and analysis data, the additive manufacturing process data, the post-fabrication data, and the parts certification qualification data that goes along with it. All of that represents the pedigree data, and all of that is really founded on the digital thread, the data management and configuration plan that we would have for a part, the engineering data that represents that part, the manufacturing plan for that part, and the quality insurance plan, the quality assurance plan for that part. So again, big thanks to Dr. Bill Frazier and Liz McMichael. We lifted this particular slide from them, and we have tailored now our approach around this approach that NavAir came up with for the data and how we represent that data in something like Camden. Next slide, please. So some takeaways, again, from that, and some continued work that needs to happen. So workforce development in data science. We need people to understand the data science piece of what we're doing. So we need to continue the whole workforce development piece of this. And I'll talk about that a little bit as I get into that particular working group. We need policies now, not only just this additive manufacturing policy, but we need policy that talks about our digital thread and our digital infrastructure. across the DoD so we can make sure that we can integrate and we can plug into that digital thread and that infrastructure across the board. We need to streamline the acquisition processes. We get the data that we need to sustain these parts and these weapon systems across their life cycle and leverage additive manufacturing to its greatest extent. We need to be more interoperable across the board, which is really kind of one of the driving forces behind what it is that we're doing with data management. We need to continue maturing Camden, continue working with Camden, not only as an experiment, but then to start working Camden operations and how we then share information widely across this Department of Defense. And we need metrics. We need to understand what we need to measure, how we need to measure those things, and then what behaviors we need to drive with those metrics going forward. So these are some key takeaways. This group, again, meets on a monthly basis, and they're doing some of the heavy lifting in terms of what we're doing technically across the board. Next slide, please. Framing the guidebook, this is where I partnered with Kelly Visconti. We brought a pretty good-sized group of people together around a couple of objectives. And the real objective here was that on the heels of issuing policy, we really need some implementation guidance at the department level that clearly articulates what we mean by that policy. If anybody knows anything about DoD policy, they're short and sweet. And we have to say a lot in a very little time. So we need implementation guidance to do this. So together with a wide group of people across many functional disciplines and through many lenses to include industry and academia, and start to try to figure out, based on the policy that we drafted, what guidance would be necessary to make sure that it was unambiguous and it was clear what it is that we were talking about in policy and what responsibilities people have specifically to implement additive manufacturing from whatever lens they're coming at this from. Next slide, please. So we set up into 3 separate subgroups. One was really kind of dealing with the business and the legal piece of additive manufacturing, the acquisition and contracting piece. One was really centered around the technical piece, again, the whole research, engineering, specifications, and the standards piece. And then one was really about the people or the cultural piece, which a lot of folks find the most challenging of implementing and executing additive manufacturing at scale across the Department of Defense. So we took a deep dive into collaboration, communication, and how we would implement and execute this policy. Next slide, please. Again, some key highlights here is that we need to establish an office of responsibility for this guidebook. And it just made perfect sense that the Office of Responsibility is the Office of the Undersecretary of Defense for Research and Engineering, because that's where the policy resides. It normally happens that way, that the group that owns the policy owns the guidance for that policy. And Research and Engineering has taken that on board, and they're resourcing the writing of this guidebook as we speak, based on the inputs that we received during this workshop. We need training and resources to implement the policy. That's another highlight here. So that came out of this, and you'll see that resonant in the guidebook as we go forward. We need a common portal information. So the Camden might be what we wind up using, hopefully in the end. It's looking very promising at this point, the way that it works, the way that it's organized. So we need to continue driving that forward as well. So next slide. And again, so it's all about the people. So we continue with workforce development. This group has been doing yeoman's work now for 3 years. They're extremely active. They meet more than on a monthly basis, and they keep working to identify and define the roles of specific additive manufacturing job descriptions across the Department of Defense and with the industrial defense base as well. They're assessing the skills and the knowledge necessary to bring those roles to life. And then they're continuously reviewing this additive manufacturing body of knowledge to figure out where the gaps are and where the workforce needs to fill in those gaps. Next slide, please. This group, again, based on activities that they've had in place now for a couple of years, they broke down into 5 separate groups, looking at five specific areas. How do we train the acquisition professionals across the Department of Defense? The DoD technicians, those folks that are actually working additive manufacturing day to day to program the additive manufacturing machines and to produce the additively manufactured components within DoD. Our engineering community really needs some indoctrination and education in additive manufacturing. Our management and leadership needs to understand what additive manufacturing is and what it isn't, and then what the potential upside to additive manufacturing can be for maintenance and sustainment, and also for performance of weapon systems in the DoD. And then industry took a key role in it this year, thinking about how would these disciplines translate into training for industry as well. A key role as well in this as well. Next slide. So some key takeaways from this was we need to standardize as much as we can across the Department of Defense and with industry in terms of our workforce development roles, responsibilities, and definitions. Across the board, we need to do a better job with collaboration, as well as we're doing in this workforce development team. There's a lot of room for improvement in terms of how we collaborate, how deeply we collaborate across the board. And there we go. My timer's going off, telling me I am almost out of time here. So I'm gonna speed up a little bit. And again, back to more communication, more integration across the board. Next slide, please. For the first time ever this year, and again, based on policy, we put together an additive manufacturing metrics team. And the objectives here really were to identify the metrics that would help us define where we are in the continuum of additive manufacturing implementation, and also to help us drive the right behaviors in areas where maybe we're a little bit weak in terms of additive manufacturing. Next slide, please. We organized into 3 separate working groups here, looking at different kinds of metrics, measures of effectiveness. What outcomes are we achieving from additive manufacturing? Are we obtaining readiness at better cost by using additive manufacturing as an example of a measure of effectiveness? Measures of capability. How many additive manufacturing, how many parts additively have we made, and how many additive manufacturing tech data packages have we approved? Measures of capability. Then measures of performance. Really comes down to, also it's a crossover here. This is how many parts have we manufactured? How many machines do we have in place? I kind of got it mixed up here. Measures of capability were really about TDPs. How many people do we have trained? How many machines might we have in place in terms of our ability to additively manufacture across the board? So again, these metrics now are being we developed a first tier level metric, and if you just go to the next slide here, like get off the stage for metrics here, really is about we have a charter team that's chartered under the Joint Additive Manufacture Working Group. It's now a stakeholder council, and we're working actively right now to pilot some initial metrics. And we'll be reporting out to the Joint Defense Manufacturing Council here in the next couple of months on how goes it with AAM metrics. Next slides. Risk categorization of additive parts. In our policy, we tell DLA that we need to integrate additive manufacturing better into the supply chain. One of the first things that we need to do is we need to come up with a common way to characterize the risk of additive manufacturing parts. And this group is working very actively on that. Next slide, please. And the real takeaway from the key highlights here is the continuing journey. We've got the JAMA initiative, which is organized and resourced by DLA, and we will continue to work across service boundaries to come up with ways where we can have common definitions and common risk categories for additive manufacturing parts, because that's really important to the next working group that DLA ran. Next slide, please, which was the Additive Manufacturing Tech Data Package group. We needed a standard DoD tech data package for additive manufacturing parts. This would be our one voice from DLA to industry, and we would solicit using a standard tech data package. That's all predicated on the earlier objective of having a common risk categorization methodology within DoD. Next slide, please. Some key highlights here is configurable packaging of TDPs is an absolute must. Part criticality drives what's in the TDPs, and we need to continue the JAMA effort and continue to work more collaboratively, not only across the DoD but with industry on doing this. Next slide, please. I know I'm out of time, but just some hot wash comments from the end. We're always looking, again, in our third year, looking to make the workshops better. Across the board, virtual was kind of key to up the numbers and make sure we could get a lot of people and get a lot of distinct ideas in our workshop this year. Folks did recommending having venues where work groups could cross collaborate. So we took that on board. Folks thought that 3 days continuous was too much for this, that shorter sprints over a longer period of time might have been more effective, and that the digital thread was left out of this particular workshop. And then for 2021, we need to include the digital thread in that piece of it. The key takeaway here is that we're working hard on these known challenges and gaps in additive manufacturing and what it's going to take us to scale additive across our department. We continue to work in our work groups on a monthly basis, and we're already in the process right now of talking about what it is that we're going to do to pull everybody back together again in 2021 and continue this journey of building capability to enable additive manufacturing across the board in DoD and with industry. And with that, I'm done. I'm a minute over, and if we have any time for questions, I'm happy to take them. Over.
I can figure out how to turn my mic on after 2 days. We'll be good. All right. No, thanks, Craig. That was fantastic. Tons to jam into a half hour. Couple questions. Can you hear me all right?
I can.
Okay, perfect. Question, any indication of when the guidebook will be released?
So we are working hard right now to make sure that the guidebook is complete with its final draft by the end of this calendar year. Once the guidebook is drafted to the working group's liking, and we have to go through a formal coordination process at that point, which will take about 2 to 3 months. So sometime toward the end of the first quarter of the new calendar year, 2021.
Got it. Perfect.
Which is really good also, John, because it's exactly right on the heels of when we think the policy is going to be issued at the end of calendar year 2020.
Perfect. Next question, how do you manage the mechanical data, how do you manage mechanical property data for raw material feedstock? Do the data sets include powder chemistry, shape, surface, size, morphology? So this all kind of falls back into, the work that Mark and team are trying to capture in that Common Data Dictionary in Camden.
Absolutely. That would be my answer to that question, is that folks are absolutely looking at that information and trying to figure out what data we currently have, what gaps we need to fill, and how we organize that information in something like Camden.
So last one we got for you is, how will the outcomes of these efforts be made available to the supply chain? So how are you sharing this information? It's great work that everyone's doing, but how do we get out there?
Yeah, that's a great question and really timely. We just posted this Monday of this week to our AMO website. So we just finished the final report. So these slides are just a real high-level overview of the kinds of things that we did and what we looked at. But the total package now is on the AMO website. for that. And after this, we can share what that
Okay, yeah,
website
we'll
is.
grab it, and I don't remember it off the top of my head, but I see Marilyn's putting some things in the chat right now. We'll post it in the chat just so everyone has it and can get access to it. But I knew it had come out, so that's perfect timing. Certainly appreciate your time today, sir. Thanks for sorry for the mix-ups early on, but we got through it. And I think it was helpful, and I honestly think this is something we continue to, we're very actively engaged. None of this is going to get done, overnight. So we got to keep working on it together.
You got it.
Thank you,
Thanks,
sir.
John.
Appreciate it. And the last formal talk of the day before we close with networking break is Amy Friedman from the U.S. Commercial Services Group. So in some ways, I think there's a nice tie between the day one and day two. The World Economic Forum, some of what Ian spoke about there, talked about the opportunity, talked about a little bit about where additive has the potential to make an impact on these big, mega trends. And, Amy and team and really the whole group at U.S. Commercial Service, we know them best from some interactions that we've had in trying to get groups of people together to go take tours overseas, get exposure to what opportunities exist and opportunity really to grow their businesses. So I know Andera I think got Amy on the line, and I'll hand it over to you. I'm not sure.
Thank you, John. Amy's going to be broadcasting through my audio and screen, just so everyone's aware. And Amy, we're ready when you are. Can you hear me, Amy?
Yes.
Okay, we're ready to go when you are.
Oh, okay.
You're live.
Hello, everyone. Thank you to the American Makes team. They had to get creative with giving me access because we had some technical difficulties with my computer. So I'm coming to you live from Cleveland, Ohio, via Teams, via the remote platform. So today I'm going to discuss kind of how the International Trade Administration within the Department of Commerce views additive manufacturing, and then my niche within the U.S. Commercial Service is export promotion. So where we see trends and opportunities and how to develop or look into creating a growth strategy within your company. So a little bit of background, the U.S. Department of Commerce has the International Trade Administration, which then houses the U.S. Commercial Service, or U.S. Foreign Commercial Service, you might hear it called. We were founded in 1980 to improve the global business environment and help U.S. organizations compete at home and abroad. In the past, or pre-commercial service, State Department handled our economic and commercial interests overseas, and businesses found that then they were getting sidelined to political pressures or other issues that might arise. So we formed U.S. Commercial Service to really focus on the business aspect of commercial diplomacy and exports. We also have within the International Trade Administration complementary units to U.S. Commercial Service, including industry and analysis and enforcement and compliance. While U.S. Foreign Commercial Service has offices throughout the world, industry and compliance and enforcement or industry and analysis and enforcement and compliance are housed in D.C. So our mission, as I mentioned, is to grow U.S. exports in an effort to create jobs and increase jobs. We're hoping that companies that export more will then hire more. So using the U.S. Commercial Service and all the other factors of the International Trade Administration, you can leverage the strength of the U.S. government for market access and research, commercial diplomacy, meeting with the right partners, and getting paid. So all very good things for a company. Our efforts supported over 1.3 million U.S. jobs between 2017 and 2019, and we see results for U.S. small businesses. That's really where we can provide a lot of value. While we do work with companies of all sizes, different size companies need different things, and so our niche is matchmaking and market access. So all you need to work with us is 51% U.S. content for your product, and just for every dollar appropriated, we returned over $300 in export or foreign direct investment for the U.S. So why should you consider exporting as a company? It's good for your bottom line is the overall goal. It gives you access. Today's improvements in trade finance, the internet and trade agreements have dramatically increased access to markets worldwide. There's more than 70% of the world's purchasing power located outside of the United States. So your competitors in Germany and France and in China are all exporting. So you want to make sure that you can too. It increases your profitability. So exporting can be a profitable business of any size. On average, sales grow faster, there's more jobs created, and employees earn more than non-exporting firms. It provides a competitive advantage. So the United States is known throughout the world for high quality, innovative goods and services and customer service and sound business practices. So you already have a built-in competitive advantage for being a U.S. company because of the reputation that U.S. goods and services have, but then you also have a competitive advantage by exporting, by increasing your sampling of your customers and clients so that you can be more adaptive and find and change your product as necessary for the changing trends. It also is really good for risk mitigation because most companies that export have an easier time riding out fluctuations in the U.S. economy and are more likely to stay in business. We saw a lot of that with the domestic downturn in 2008, which probably moving forward with where the world is right now, mitigating that risk is important as well. So overall, the economic impact of exporting is extremely important to the U.S. The U.S. exports of goods and services totaled $2.5 billion in 2019, and U.S. companies exported to over 53 countries in 2019. And according to a study published by the Institute for International Economics, the U.S. companies that export not only grow faster, but are nearly 8.5% less likely to go out of business than non-exporting companies. So I'm really nailing that point in there. And again, more than 70% of the world's purchasing power is outside of the U.S., and your competitors are exporting. They are selling to people outside of the U.S. So when I'm going to go into talking a little bit about trade data and how our industry and analysis team and International Trade Administration sees advanced manufacturing and additive manufacturing. And I just want to be clear that this is the definition that we're using, the NIST Advanced Manufacturing Office's definition of the term. So whenever I'm talking about the trade stats or trends that we're seeing in different markets, these are the types of things we're focusing on in that. So, we acknowledge the first patent was just over 33 years old with 3D systems. There's cumulative annual growth rate of 26.7% over the last 30 years. There's no official harmonized tariff schedule or NAICS code, so the true value is hard to quantify. But we do complementary goods, we do other areas where we might be able to capture that information for the trade stats. So global trade for the industry is at $11.8 billion in 2019, which is a 21.5% increase from 2018. U.S. is the world's top supplier of industrial automation products, digital services, and 3D printing equipment. And AM has caught on, as they say, to industries ramping up as applications integrated at scale. So as it's become more adapted, you probably all know this, it's becoming more and more popular because you can do it at scale. Previously used as prototyping or modeling, now used increasingly for functional parts. So for additive manufacturing in the United States, a large portion of the world's AM companies have their roots here, and the United States has, by a large margin, the majority of operational printers in the world. As you can see in that chart, the US is well over the amount of other countries that are bundled together, and then it goes into specific countries. So there's a lot of operational centers in the US. Competition is growing fast, and the number of installed printers are ramping up, but the geographic inventory is rapidly diversifying. And then some other information about systems sold and what the US landscape is. So for additive manufacturing's top industries, we see that it's in 3. We have industrial, machinery, aerospace, and automotive. Each industry is looking for integration of additive into its global supply chains. So you see, you'll see in the country reports that I'm going to go through how one company might be headquartered in Italy, but they're looking for a supplier for all of their offices throughout the world. A functional part manufacturing is the fastest growing focus area for AM, and various benefits, but some of the most salient that we see are lightweighting, complex parts, diverse materials, reduced or no tooling, part consolidation, time reduction, and the fastest growing industries that we see from 2019 are academia and medical and dental applications. So some highlighted projects that our industry and analysis team wanted to make known. We have 3D printing can be used to produce many types of machine tools such as jigs, dies, and fixtures. Tools are typically custom made and produced in low quantities, a perfect space for additive. And America Makes with Missouri University of Science and Technology study showed rapid tooling for composite manufacturing and part integrity. And results, 3D printed parts were preferable. They saved the producer material costs and time. In aerospace, you have lightweighting, which is particularly important. A large portion of AM R&D carried out is for aerospace, both in defense and commercial applications. The regulations and standards are particularly stringent, and everybody probably knows about GE fuel nozzle, and the Boeing and small, medium, and enterprise joint projects produced 600 3D printed parts for the NASA Starliner. In the automotive sector, we saw an early and prolific use of 3D, but mainly for prototyping. Now the focus is to unlock the potential to reduce costs within the supply chain. You have Divergent 3D that's connecting composite materials and 3D printed parts, HP Additive that's commercializing and integrating metal printed parts into particular models. And within the medical sector, you have medical and dental, which are often considered separate end-use sectors within AM, but it's a well-suited place for development. Most of all of its benefits apply directly in process. You have facial and skull implants and printing synthetic organs out of tissues for R&D trials. So a lot of things going on in those sectors. So part of what we can do with commercial service and industry and analysis is provide information. As you're looking to export, now that you maybe in your company have identified what sectors have the great potential, where you can apply your technology and your goods, where do you send it? So part of what we provide on behalf of the U.S. government to U.S. companies is our country commercial guides. And this is market conditions, opportunities, regulations, business customs for 125 plus countries, updated annually. It's really a really high level look at what it is to do business in a specific market. Then you have your industry solutions. So We do pride ourselves on being able to tap into certain industry sectors, and advanced manufacturing is one of them. So we have our office in DC that focuses on it, but we also have a global team dedicated to knowing about what's going on in the industry. And the website for that is on our trade.gov advanced manufacturing industry website. And we do specific trade events, attend trade shows, put out market entry intelligence, do trade missions that are focused on that specific industry. We do other industries as well, such as education and healthcare, but we have one specific to advanced manufacturing is for this audience. We also do top market reports that go in a little bit more depth by industry or country, with case studies, examples, and specific data, and then regulatory insight. So looking at upcoming regulation and information on how to comply. We also do a lot of roundtables with stakeholders within specific industries to discuss standards and make sure that there's a level playing field for US technology outside of the country. So some of the information that our team was able to pull on where there's opportunity for additive manufacturing applications. First, we'll go by region. We have Europe. So about 95 system manufacturers selling in bulk of European AM products. Germany leads the way, particularly in metals. Germany houses companies like EOS, EnvisionTech, and Trumpf, and is a premier site for US companies' presence in the EU, such as GE. It's also home to the Formnext conference, as well as a hotspot for industrial R&D. And I had the opportunity to go to Formnext this past November. It was incredible seeing all of the technology and different applications that can be used with additive manufacturing. We were able to take 9 US companies to the show, and then in addition we went to Poland and France for them to promote their companies and find partners in sales. I'll go into that in a little bit. We also have France as a rising player with companies like BAM, AddUp, and Prodways. They also have clusters identified, and Italy follows suit behind Germany and France, as well as many other economies such as Netherlands, Sweden, and Poland. In Asia, you also have an increase in sales. An estimated 30% of all industrial systems installed across the globe are located in the Asian Pacific region. China has made some headway and serious investments, and their stock of printers is growing and its technology is becoming more advanced. Japan operates solidly in high-end production of AM with companies like Nimaka and JKEKT, known for its hybrid applications. Singapore is not a huge producer, but it is essential for international collaboration on policy standards and technology development. So honorable mention to Singapore. A bit deeper dive into Germany and Italy. You have 15 million people directly or indirectly involved with intelligent advanced manufacturing, and 75% of German companies across most industries have implemented some sort of digital solution or plan to use Industry 4.0. Looking for solutions such as SaaS, IS, PS, sorry if I'm butchering these technical names, or cloud computing. Key industries investing in technology are automotive, machinery and equipment, plant engineering, metalworking, microelectronics, logistics, medical, process technologies, and retail. So there's a lot of different ways to sell into the market for your technology. And there's lots of government investment as well, and research identifying clusters. So Germany, bottom line, is a great opportunity for partnerships, and there's a lot of growth and innovation there. Italy is the second largest manufacturing country in Europe. It's quickly adapting intelligent manufacturing for Italian and worldwide locations. That goes into what I was saying before, where they might be headquartered in Italy and be able to take advantage of the incentives that the Italian government has put in place to implement, and then they're going to expand that usage into their worldwide locations. You have Milan's Politecnico University survey which incorporated 100 large and 525 SMEs to understand the demand, most common applications for AM, and they found that factory management, logistics, and inventory control were most popular. And as I mentioned, government incentives for advanced manufacturing solutions are continuing to develop. So other markets to note, you have Israel. They have knowledge developed and they've created companies and improved technology, increased involvement in leading industries. Brazil is an incoming market, beginning to invest more heavily into AM, and there's increased involvement in partnerships with educational institutions. And South Africa, AM received strong government support with programs such as Rapidasa, providing funding to over 50 startup companies, and stock of AM machines has risen sharply, but mostly for desktop printers. So I've kind of laid the groundwork of who I am, what my department does, why you should export, and where we kind of see opportunities in the world. And now we'll just briefly look internally into your company and give some guidelines on, or some best practices and ideas on how to streamline your growth and develop a strategy for strategic market selection and finding partners. So when you're developing your international strategy, you want to have an internal assessment, you want to identify resources, and then you want to implement. Your internal assessment should look at whether your company is reactive or proactive. So are you seeking opportunities, or are you waiting for leads to come to you? Looking at how your sales are actually found if you're at that stage. And do you have management buy-in and a corporate culture conducive to international sales? So are there standard operating procedures in place for export transactions? Do you have a value proposition and statement that identifies that you are an internationally minded company and looking for sales overseas? And do you have the resources, so personnel, money, training available to support international business? So one of the key things to do with an international sale in your internal assessment is also identifying what each person's role is in the sale. So for compliance, you have US export laws you have to adhere to, and then you have the import requirements of the market you're selling to. You also have finance. So how are you going to get paid? Are you making sure you do your due diligence and it's a sound entity that can pay you? Do you need insurance? How are you going to, what terms are you going to offer? And what currency are you going to sell in? And production, so, what are you doing? Free trade agreement sourcing, and you need to comply with that. Do you have to do products in different languages or manuals in different languages? Then sales, so again, back to how are you going to get leads? How are you looking and selecting markets? How are you generating leads? And what are your sales channels? Are you going through a distributor? Are you going through an agent? What does that look like? And then shipping, how do you get your product from point A to point B? What documents are required? Things like that. And it may sound super intimidating. It's really not, and that's where we come in and help, or can connect you with service providers that really know what they're doing and can make this way less intimidating than it is. Your external resources, so what industry events do you go to? Do you go to trade shows? Do you go to conferences? Obviously all of you go to conferences because you're at this one. Webinars to attend for training, incubators that you can be involved with, universities you can be involved with, local economic development organizations, district export councils, U.S. government programs. You have the U.S. Commercial Service available to help with trade counseling and training, trade missions, market research. You have Small Business Administration available to help with training and counseling as well, and STEP funding through the Ohio Image Grant, which is money in your pocket for export promotion up to about $10,000. There's also resources for startups and Ohio Development Service agencies or state level resources wherever your company is located within the states may be available. So I mentioned before we have our advanced manufacturing team to provide specific information and events. So we just had our manufacturing day webinar. We've had gentlemen from American Makes speak on our other webinars that we've hosted. So lots of free information available to help you understand what your position might be in the world when it comes to your business and exporting, what opportunities there are, what the landscape looks like, what the trends are, things like that. So I encourage you to go to our website. It's a bit fun to try and find specific things sometimes, but you can access the link and go to trade.gov and look at advanced manufacturing. Then you'll get into our top market reports that specifically have plastics, materials and machinery guide, industrial automation, manufacturing technology. So really insight into what those subsectors or what those industries have to offer in terms of exporting. So you've looked at your SOPs and you've looked at where you could go. You've looked at your internal and external resources, and now you can implement your strategy. So put the SOPs in place, set realistic goals, determine your target markets, use the resources available to you, and start making deals. And I'll touch a little bit on the strategic market selection. And that just goes into knowing your customer, knowing your product, identifying the variables that play into what makes them purchase your product, and weighing the variables and prioritizing, and then finding those opportunities. So key things to know about your customer: who is the decision maker, who is the influencer, where is the money coming from, what is their motivation for using your product or service, and why is this person looking for your product? And then you also have to consider how culture will play a role in the decision to purchase or implement your technology. And it could all be the same person, or it could be different people, and you have to schmooze all of them. And then knowing your product, so making sure you know your competitive advantage. If there's a problem, is there a problem you can solve with your product? Is price an issue? You can't always go in at just lower price. I think with the technology and everything, that's not necessarily an issue for the audience, but just be aware. Does the product need to be adapted to the market size, language, colors, interface? And do you have a harmonized tariff code? So that might help determine your trade statistics, like flow of goods or compliance. So finding opportunities, I've mentioned a couple times, there's trade missions, there's website globalization, making sure your website looks and expresses that you're open for business internationally, finding partners individually with business-to-business meetings and matchmaking, going to trade shows, or utilizing your existing network. So I mentioned we were able to go to Formnext last November. We started in France, and this is just an example of one of the companies. I'm not able to disclose the company's name, but I am able to disclose some of their results. So they participated on our trade mission with us and traveled first to France and had market briefings, meetings with a cluster outside of Paris that focuses on additive manufacturing, and then business-to-business meetings with selected potential partners. Then we went to Formnext, and they were able to meet again on the show floor at the U.S. Commercial Service booth with potential distributors and clients and customers that our specialists in that market brought to meet with them. And then they went to Poland with us, where we had additional meetings and market briefings and presentations. So at each stop, the participants spoke with multiple partners and customers, and after attending the mission, company has an increased understanding of the market, had a chance to speak about regulatory and standards, and reported over $7 million in sales between Polish and German contacts met through our specialist overseas and through the program. So, you know, we always say you're gonna export. If you have a competitively advantaged product or technology, your customers are gonna find you. But we wanna be there to help you do it right, to make sure you don't get burned in the process, and also to get you there faster potentially and make your time more effective. So with that, that wraps up everything I have to say, I think, right now, unless there's any questions or comments on what I covered. I know I was kind of all over the place with information, and I did let John and Tara know that this can be shared. This is, you know, public information if anybody wants.
Perfect.
So I just want to make sure that you can hear John. Can you hear John, Amy?
Hello.
I heard him. Yeah.
Hello, Amy.
Is there any feedback?
No, it doesn't sound like it.
Perfect.
Well, hello, Amy. Thank you. Thanks for working through everything with us. This has been a really interesting presentation. I don't think it's something that we've hit on much. I know we've talked a little bit, but we've never really brought this kind of content. And we had I don't know if you happened to be on yesterday morning, but we did have the World Economic Forum on, and they talked about, you know, some of the opportunity that exists, or what the perceived opportunity might look like. It was nice to kind of bookend that with your talk about different ways that you can take advantage of programs that actually exist and have been put in place to try to help people out. So hopefully we'll, you know, get together again at some point and actually go to Formnext next year when it all, you know, things are opened back up, but we'll see how that all shakes out. Question in the meantime, are you tracking additive manufacturing international business competition from China and Russia? So do you have that data? Are you seeing that? Maybe do you trust it? Anywhere in that spectrum would be great to hear about.
Yeah, I think, you know, our industry and analysis team is looking at where the competition is coming from, and what they look more at what regulations are being put into place or what standards are being put into place that might hinder U.S. commercial viability in those markets. But they are looking at what innovation or what technology is coming up within the sector in those markets as well, and what trade. Like I said, it's kind of hard to track trade in the sector because there's not necessarily an HTS code or some sort of data point that we could follow. But I do know that from a U.S. competitive standpoint, our team is looking to see what's going on in those markets to make sure that the U.S. is at least aware of the trends going on. So whether it's our industry and analysis team looking at that, we have desk officers in DC that might be looking at that from a country perspective. But we also have our advanced manufacturing specialists within the embassies in markets all over the world that are looking at what's going on that might affect U.S. opportunity there.
So just building off of that really quickly, you made me think of something. So you've mentioned, you know, these various groups that are helping, you know, ultimately protect our opportunities. How is that information shared? I mean, is there something where, I don't know, whether it would be annually, or how do the teams that are working on this actually get this content out to the community? So today is a great way of doing that. It sounds like you do webinars and things like that. Is there published content annually or on some basis that summarizes this space specifically?
Yeah. If you go to the trade.gov additive manufacturing web or advanced manufacturing website, and I'm just going to try and pull it up. We'll see if the technology lets me. but if you go on there, there's a lot of information. We're constantly putting on webinars. We're constantly putting out information about that. On a market by market basis, we've been having these advanced manufacturing talks. We just ended an advanced manufacturing 3-day or intelligent manufacturing, it's called 3-day program called Discover Global Markets. So we are putting that information out kind of in mass on our website or through our webinars, but then we're also, that information is available country by country for our clients. So depending on where your company is located, if you were interested in learning more about what's going on in advanced manufacturing in Brazil, I don't know if everybody can see my screen now, but this is the website. If you're interested in knowing more about what's going on in 3D additive manufacturing in Brazil or anything like that, we could have a call one-on-one with our specialist in that market to talk about your specific technology and where there's potential in that market or what's going on with it in that market. We also encourage people to sign up for our newsletters, because that's how our industry teams specifically send out any updates or any events that they might be having that would be pertinent to what you're doing.
Got it. Perfect. No, that's very helpful. The question just came in. So, the question up above it, I don't know if you can see them in the Q&A, but it was the question about China and Russia, and in particular, what's going on over there. I believe the next question is a bit of a follow-up to that, which says, how does export regulations to those regions shape out, or how are they shaping out, specifically thinking about China and Russia?
Yeah, so you'd have to worry about, your export regulations, and it was to Russia and China. Those were the two countries, correct?
Yes.
All right, I can see. Okay, so those are very tricky export destinations from an export control standpoint to begin with. That's probably why the person asked it. So Russia, anybody within a supply chain that might be an entity, a not good entity, might be an issue. For China, you're worrying about intellectual property, so you have to be aware of that, and then the restrictions on your technology. So for your export compliance, you want to make sure that you're familiar with Bureau of Industry and Security and your commodity control classification. And then what I would recommend, if you're doing business in those markets, particularly in China, be very careful of your intellectual property. But in Russia, do your due diligence. So business is still open there. We still have an office there, and we do service it. So you could do a due diligence. We have something called an international company profile, or ICP, or you can go through a private entity to do it. But if you are going to do business in Russia, I would make sure that you do extensive due diligence to make sure that who you're selling to is not on the denied parties list, and that nobody affiliated at all with the company is on the denied parties list. And then with China, you just want to make sure that you're complying with the restrictions that are put in place through BIS and OFAC there as well. And that's true for any country. It's just, it's ever changing with Russia. And then in China, you have the additional issues of IPR that are a little bit heightened there, more so than in some other markets.
Perfect. Well, that wraps up our questions. So thank you, Amy, so much. I think we could talk for a long time about this topic, and maybe we can put something on the schedule, next year at some point to re-engage the community just around this topic. I think there's quite a bit of opportunity, but a lot of things people need to consider when they're getting engaged. But we all know it's a global economy, and we need to be playing across the globe. So.
Yeah. And stuff I didn't necessarily touch on, but we also are here to help with like supply chain management. I mentioned a little bit that we do foreign direct investment and stuff like that, but we also work with economic development agency to help with supply chain issues and, finding partners for innovation and things like that. I just really appreciate the opportunity to speak to the group, because I've attended in the past, and it's a great conference. So thank you very much for inviting me to speak.
Hopefully next year you'll get to drive down and we'll be together in Youngstown again, all as a big group. So thank you so much. That concludes our content for today. We're going to shift into a closeout reception here in a couple of minutes, but just wanted to wrap up. I think overall 2 days have been fantastic. We very much as an institute are thinking about what do we need to be delivering for membership, and ultimately where do we need to be going. So I talked yesterday morning about this idea of strategic positioning, strategic leadership, strategic communications, and becoming the front door of additive manufacturing. I think together with the community we have here today, we've got tremendous opportunity. We heard about it from, whether you look at it from the global opportunity to what we heard in the AMCPR talk, which is really talking about supply chain agility and resiliency, to the Amnl program and opportunities in medical, and the list goes on and on. There's tremendous opportunity for this technology. It was also interesting, a note I just wrote down that Amy referenced, and actually Ambassador Barnes mentioned earlier in the day, the shift towards using the technology as a production capable tool. We're all seeing that. We're seeing the opportunities rise across a variety of different industry sectors. To hear her say that functional parts are the largest area of growth is, it really speaks to that. It's showing that we're making, not just making progress, but we're making a shift. So I think we need to continue the conversation. We're going to break off here in a minute. In closing, I just wanted to thank the team who is really behind all of this working. So Tara Sarver on our team leads all of our events, and many of you know her just from interacting over the years. I think if we can virtually clap, everyone do it at home. This has been fantastic. I personally like this venue, more than any others, and we've been on lots of them, just like all of you. But it all works because of the time that the team, and her in particular, puts into making this all come together and bringing the 25 different presenters together over the past couple of weeks to get them in the position that, we still have quirks, we always have quirks, but overall everything worked out really well. And Andera from Link 3D is just amazing to work with. And you saw just in the acrobatics in that last talk in presenting a different person's team's drive to get us to the point that we could get her to talk is amazing. So appreciate everyone's help. There's a lot of people that go into this outside of that as well, and within our core team and beyond to make all of it happen so that you understand what we care about and ultimately we deliver for you as a institute. Continuing with that theme, there's a number of upcoming events happening. So the next activity that we have scheduled is a virtual game day. More details on that will be coming out very soon, but it's scheduled for November 19th. We've had a lot of success. We've had tremendous results and response from people getting engaged. That short half-day venue is proven to be valued by most who are calling in. I mentioned yesterday this idea of our desire, and we've now got on the schedule on December 10th to do a mini TRX. There's going to be some focus on standards and beyond on that. So look for that information to be coming out very soon. We know we're working, we're all close to finalizing a March 2021 TRX event. Fingers crossed, we're going to be going virtual. We're going to be live. That is the dream. We'll see how it all works out, but overwhelming response from the community was to try to get back to live in spring. Obviously, we'll do what makes the most sense and keeps everyone safe. That's the top priority for everyone, as it should be. And then we know next summer we'll be doing a TRX physically at Ohio State. We were unable to do that this past year, even though they were huge supporters and were able to pull together content and do the virtual TRX this summer. So with that, thank you all for coming. Thank you for hanging out and sticking with us. We've got the reception coming up. Josh Kramer just told me he's giving out free t-shirts for the first group of folks that come to the Education and Workforce Development table. So rush to see him and hold him to it. And thank you all. Appreciate your time, and we'll be in touch soon.